Good evening, all of you. A warm welcome to all of you for this session on the analysis and detailed solutions of ESE 2022 Prelims exam for Electronics and Communication Engineering for paper 2. I hope and pray that all the students have written the exam well, and we are going to meet again for the mains exam in future. Here we are having plethora of faculty to discuss, analyze and give the detailed solutions for all the questions that have appeared in the examination. In fact, we are trying to emulate the examination classroom when you are writing the exam for ESE. Means we try to answer these 150 questions in less than or equal to 180 minutes. So we are trying to see that by the process of elimination and by the process of understanding the fundamentals, how to answer to these questions very quickly. Of course, in some of the questions it may not be possible, but in most of the questions that is going to be the criteria. So while solving, we all faculty members are going to follow this procedure and we try to answer in a successful manner within the stipulated time. If you look at the analysis of the questions, okay, distribution of the marks, in 2022 ESE Prelims exam, these are the marks given here. You can see how the trend is changing also. Okay? So for the past 4 years, including 2022, what is the marks distribution has been given here. Some of the subjects, they got more number of questions this year compared to yesterday years. For example, analog and digital communication, as usual, it is going to play a prime important role in any examination. And apart from that, computer organization and architecture is gaining the ground. It has got totally 17 marks this time. And if you come down, the advanced communication topic. So usually, which is going to play a very important role, as I said in the class also. So this is going to be very crucial to get a good rank in the ESE exam. So we got totally 16 marks in that. Material science. So this is the last subject, 10th one. In that one, we got 16 marks, okay, 12 marks in 2022. Of course, on average, we are getting almost same number of marks in this particular subject. Okay, so this is what the distribution of the marks here, and while answering, we will tell for other subjects how the marks have come here. So now I request my colleague ML Narasimham to come and discuss the questions on signals and systems.
Thank you, Dr. Chakrabarti sir. Sorry for the delay. From signals, this year we got 5 questions, 2 from that advanced electronics topic. Other 3 questions are very simple. Let us see what we got. Consider the following statements regarding signals. Out of the 3 given statements, we have to observe which are the correct statements. Deterministic signal is a signal about which there is no uncertainty. That is true. You can represent either in mathematical form or graphical form. That is correct. Each signal within the ensemble has certain probability of occurrence, and the ensemble of signals is referred to as random process. That is also true statement. Electroencephalogram, EEG, is a random signal. It is a pseudo-random noise generator. So, what is the correct option here? All 3 options are correct. All 3 options are correct. That is the correct answer. 1, 2, 3. Option D is the correct answer. All 3 statements are correct. Let us see the next model. Cour filter question. When we are designing the filters, we learn different forms of filters like Butterworth, Chebyshev, elliptical. Elliptical filter is also called as Cour filter. Elliptical filter is also called as Cour filter. Cour filter has ripples in both passband and stopband. When you draw the characteristics roughly, you can have ripples both in passband and stopband. But what is Chebyshev system? Type 1 will have ripples in passband. Type 2 will have ripples in stopband. So what is the given statement? Another theoretical question for us. Cour filter has equiripple passband and stopband. Equiripple passband and stopband. Of course, it is correct. We can maintain equiripples in passband and stopband. What is the second statement given? For a given filter order, passband, stopband deviations, Cour filter have more transition bandwidth compared to Chebyshev. That is false statement. The reason is, when you are going from passband to stopband, this gap we are calling as transition band. This is more for Chebyshev, less for elliptical. It is almost like ideal case, less for elliptical. So second statement is incorrect. Actually, they have missed, I think, one more statement. Third statement is also there. What is the third statement is? In typing, probably it is missed. In third statement is, Chebyshev filters can reduce the order. Of course, it is correct. So according to the given options, 1 and 3 are correct. So which option? B option is correct. 1 and 3 only. They missed the third statement. Okay? That is another theoretical question we got. Let us see the next model. Which of the following statement is correct for the given system? Funny question. Very simple model. What is the given system expression? What is the given system expression is? Yn equals to x square n plus 1 by x square n minus 1. X square n is clearly non-linear operation. X square n is clearly non-linear operation. The other property asked is shift invariant, means time invariant. What is time invariant condition? A delay in the input signal causes same delay in the output signal. There is no external dependency on time index. So 100% it is system time invariant, also called as shift invariant. What is causality condition? Present output should depend on present and past input. Output index n, input index also n minus 1. The present output depends on present input and past samples only. So what is the correct option, sir? Non-linear, causal and shift invariant. Non-linear, causal and shift invariant. This is very simple model, habituated question in our classroom discussion. Output is given for how many samples? Output is given for 7 samples. System is given for 5 samples. Output known, system known, input is unknown. Which concept? Deconvolution. We habituated to one statement, input has m samples, system has n number of samples, output length is what? M plus n minus 1 samples, m plus n minus 1. What is the length of output here, sir? 7 samples. System is defined for 5 samples. So m value 5, m plus n minus 1 value is 7. m plus n minus 1 is 7. M value. So what must be the length of the input? Only 3 samples. Choice is between A and B. Elimination of 2 options directly. Elimination of 2 options. Between A and B, what we have to do? To get the unknown samples, some mathematical enjoyment is needed. Assuming the unknown samples like A, B, C, make the product and comparing the columns. Our luck here is find the first sample, it will decide which is correct answer. Why? Find only the first sample. Suppose you are multiplying by A, 2A, 0, minus A, minus 3A like that. So by comparison, what is 2A? Equals to 2 means A is how much? 1. So out of A and B, which is correct? First one is correct. That is the beauty of engineering services paper. Elimination of options. This is another standard question. Window characteristics. Standard table we have provided in the classroom discussion. It is asked the width of main lobe for Blackman window. Blackman window, stop band attenuation negligible. So what is the width of the main lobe? Standard relations are 12 pi by n. Straightforward question. Straightforward question. So these are the simple models that were concentrated. Advanced electronics, that topics, filters design, that fellow has given more concentration. Out of the 5 questions, 3 models are from that topic. Okay, that's all. Next I am forwarding the discussion to Dr. Ganapati Reddy sir.
Okay, I am Professor Ganapati Reddy. In this network total, this time 14 questions came. I think maximum number of questions came this time. So let me go through the questions and with answers. What is the value of source current IS of the given network shown in figure? Here concept is simple, but only thing is you have to do patiently, and it form a bridge network. It appear like a bridge network. Bridge is not balanced. If bridge is balanced, we can solve easily. So bridge is not balanced, and series parallel not possible. You have to convert this delta into star or this delta into star. So these here values are less, probably this is best option. So this change into star. 4 into 6, 24 by 19. This will be 54 by 19, 36 by 19. Then later add these two. Add these two, then add these two. These two are parallel, that is series with this. So simple concept, these two series parallel, then add with this. Then IS is nothing but 12 divided by total R equivalent, you will get 10. So answer is 1.2 amps. Option C. Next question. Which of the following properties of the circuit of a graph are correct? Minimum number of branches possible in a circuit will be equal to number of nodes or vertices. Nodes are, this word vertices is used in author Atre. So if you take one typical example, so this is called as a node or vertex, and minimum number of branches in the tree, these are called as branches. Minimum number of branches possible in a circuit will be equal to number of nodes or vertices. So if you neglect this ground, it is equal. So this is one possibility. And there are exactly two paths between any pair of vertices. This and this, if it is a pair, exactly two paths not possible. So 2 is wrong. There are at least two branches in a circuit. There are at least two branches in a circuit. Circuit means closed loop. So in this closed loop, these two branches. In this closed loop, these two. In this closed loop, these two. So this third is possible. Therefore 1 and 3. So B is the correct option. Next question, what are the open circuit reverse voltage gain? Reverse voltage gain means V2 by V1 is a forward voltage, V1 by V2 is reverse. V1 by V2 is the reverse voltage gain, but under open circuit, this open not mentioned either input or output, depending on the option, here you have to make open. So this is port V1 and V2, this port is open, and I1 equal to 0. I1 equal to 0. So we want V1 by V2. When this port is open, this current is 0, drop here is 0. So V1 exactly across this. V1 exactly this. So V1 is equal to what? This V2 is dividing between 3 and 6. When it is open, these two become series. So V2 into 6 by total 9. So it will be 2 by 3 V2. We want V1 by V2, so 2 by 3. So 2 by 3 is 1. Then next is asking short circuit forward current gain. For short circuit forward current gain. So short can be this side or this side, but answers will match only when you short this. This side is short. So this current is I2, short circuit forward current gain. Forward current gain means I2 by I1. I2 by I1 when this port is short. Now this is there. Now when this is shorted, what is the current entering here? I1 is entering. This current is dividing between these two. So if I write equation for short circuit I2, this current minus I2, this current will be, incoming is I1 and that is dividing between these two into 6 by 3. So it will be 2I1. I1 current is dividing. 6 by 9, total is 9. So it will be 2 by 3. So we want I2 by I1. we want I2 by I1, so you will get minus 2 by 3. Minus 2 by 3, 2 by 3. So option C is correct. So this only confusion in this problem is open, it can be this side or this side. Short, it can be this side or this side, but depending on the answers, you have to select this side short or this side short. That is only the confusion in this problem. Then what are the open circuit? Open circuit again, transfer admittance. Admittance means current by voltage. So it's a transfer again, this is V2, I2, V1, I1. Is asking open, so this side only open, otherwise answer will not match. And admittance is I2 by V1. I2 by V1. So when this is open, I1 will be 0. And this I2, some current will flow here, some current will flow here. So assume this current as I2 prime. So what is I2 prime? I2 is entering and opposite is 10.5 by 10.5 plus 21 plus 42. This is I2 prime. What we want? V1. So V1 equal to I2 prime into 42. What is I2 prime is I2 into 42 into 10.5 by 10.5 plus 21 plus 42. So simplify you will get 6. This value is 6. So V1 is equal to 6 I2. And what we want is I2 by V1. So this will be 1 by 6. Next he asked negative short circuit current ratio. Negative short circuit current ratio. So it is what is current ratio? I2 by I1 is asking, minus I2 by I1 is asking. And a short circuit. So make this is short. When this is short, V2 will be 0. So this will be 0, this is shorted. Under this condition we have to find. Now I1 is there. This is shorted. Now we have to make a relationship between I2 and I1. Now once this is shorted, current will not flow here. So directly we can write this current minus I2, what is entering is I1. Entering is I1, we want this side, so into 42 divided by 42 plus 21. So just to simplify, you will get answer 2 by 3. So option C is correct. These are dynamics of the nth order single input. So number of inputs are single and single output. So it is like a single input, single output system written by the vector matrix, a differential equation. This comes under state equations. So Ax plus Bu in this form and output equation is also given. What is the size of the output coupling matrix? So C matrix is asking. So state equation's general form is y is equal to Cx plus du. So that is not there anyway. Is asking C size of C. So standard size of C is Q by N, and Q is number of inputs. Number of inputs. So number of inputs given 1. So definitely it is 1 by N. So C is the correct. For the state variable formulation of RLC network, which of the following statement is correct? So here just directly I am going to D, current through the inductor is the state variable. A standard concept, current is the state variable in inductor, voltage is the state variable in the capacitor. So that condition is satisfied only D, so D is correct. This problem options not matching, so something wrong in the options what is given. Yeah. So if you write the equation I is equal to IR plus IL plus IC. Now state variable in capacitor is assuming like a X2. This voltage is X2. So X2 is one statable, that is the voltage in capacitor Vc. And current through inductor is another state variable, this is X1. So what is I given? I naught sin omega t, then IR is nothing but voltage by resistance. What is voltage? X2. So X2 by R. Then current flowing through inductor is IL. IL is nothing but X1 plus IC. So what is IC value is C dVc by dt. So this is nothing but C derivative of this. So X2 dot. Now from this what is X2 dot? Is I naught sin omega t by C, then minus X1 by C minus X2 by RC. So when we are writing in matrix form, X1 dot, here whatever options given not matching, so new answer is this, X1, X2, so X2 dot is what? Here X1. So minus 1 by C, here minus 1 by RC, and here 0 will come. Here I naught by C sin omega t. Then what about this? If you see here, IC equal to this one. Yeah, this voltage V2 is equal to L di by dt. L dIL by dt. So that is nothing but X1 dot. So what is X1 dot is nothing but X2 by L. X1 dot equal to X2 by L. So X1 dot this will be 0, here 1 by L. So X1 dot equal to 0, 1 by L X2, 0 satisfied. X2 dot equal to this into this, this into this. So this is the correct, but this option not given. So this is the correct answer. All these options given wrong. Now this is again a transient problem. In the figure, switch is thrown from position 1 to 2 at t equal to 0, moving from 1 to 2. Just before the switch is thrown, the initial conditions are given. Current is 2 amps, voltage is 2 volts. What is the current I of t after switching action? So you have to draw the equivalent circuit after it is connected to 2. This is 5 volts, 3 ohms, and 1 Henry, 1 by 2 farad, and here initial voltage is 2 volts, initial current is 2 amps. So we have to find the expression for current. It is the second order. So 5 is equal to 3I plus LdI by dt, 1 di by dt plus 1 by C, so it will become 2, then di by dt, sorry, 2, 1 by C integral I of t dt 0 to t, initial voltage 2. So because of this integral we have to differentiate, 0 equal to 3 into di by dt plus d square I by dt square plus I 2I, derivative of this will be 0. So you will get d square plus 3d plus 2 into I equal to 0. So solve this equation, you will get the roots like this. Roots will be minus 1 and minus 2. So just to solve the second order, you will get roots minus 1, minus 2. So what is the option is here? If you see, actually it is a plus. In what is the initial current? Initial current, logically if you see, I0 plus is 2 amps, so steady state current will be 0. So exponentially it will decrease. So these negatives, one of A or B will be correct. But at t equal to 0, this is coming to, this is also coming to initially. Infinite, this is 0, this is also 0. So we have to decide either this or this, not from this, from the roots. From the roots minus 1, minus 2. So therefore B will be correct. Based on this roots only I am deciding B is correct. And these two, this condition is satisfied by A and B, and B is selected based on the roots. So that's the logic. Then what is the output voltage? V0 of the circuit shown in figure. Here RC circuit is a first order, but input itself an exponential input is given. So overall it is not a first order, overall it is a second order. That is the complexity of the problem. So you have to write the equation, shortcut method you can't apply. So 3 e power minus t, that is given in milliamps, is equal to, so this voltage is V0 and this current is V0 by 10K. Then current flowing through capacitor is C dV by dt, 25 micro dV0 by dt. So solve this equation using Laplace transform. Even if you mathematical, it takes more time. So best option is solve using Laplace transform. So Laplace equation, just a final equation I am giving, you will get 120 by s plus 1 into s plus 4. Use partial fractions, find out A and B, then solve for V0 of t. You will get 40 into e power minus t minus e power minus 4t. So option C is correct. So only thing is fastly you have to solve using Laplace transform. The value of E, here 100 volts given, R is 10K, C is 10 millifarad in the circuit shown in figure. The capacitor current IC, so this current at 150 milliamps is asking. So it is clearly a first order circuit. Initial current IC 0 plus. Initially capacitor is shorted, so 100 by 10K. 100 by 10K, so this is 10 milliamps. Then IC infinite, open it will be 0. Then find out tau is RC. R is 10K and C given 10 millifarad. 10 milli 10 power minus 3, this will go, so it is 100. So initial value, final value, tau, write the expression for I of t. So finally 0, initial will be 10 milliamps, 10 milli e power minus t by tau, t by 100. So this is the answer. So it is milli already there. This you simplify, you will get C option. Actually this value is also in milli, not written, but 10 e power minus 1.5 milliampere like that given. So C is correct. The capacity of the figure shown below has 25 volts on it with polarity shown. At the time switch is closed, the expression for Vc of t. Again it is a first order circuit, comfortably you can use a shortcut method. So he is asking expression for Vc. So what is Vc0 plus? Vc0 plus 20, the capacitor is having 25 volts initial voltage. What is given? Vc0 minus 25 volts, Vc0 plus also 25 volts, then Vc infinite. Steady state it is open, charge it to 40, so this is 40. Now straight away Vc of t is equal to final 40 plus initial 25 minus 40 e power minus t by tau. This tau you have to find. Tau equal to Rc, R is 200, C is 1000, 10 power minus 6. So that if you simplify, you will get to tau of 5. So final answer is 40 minus 15 e power minus 5t. So option A. So 25 minus 40 is minus 15. This is the answer. These are straightforward. Any first order we can solve easily like this. What is the value of maximum power transfer? Maximum power transferred to the load resistor RL in the given circuit. So two sources are there, and maximum power transfer is nothing but extension of Thevenin's theorem. So first replace the network with the Thevenin equivalent. Find out R Thevenin, V Thevenin, RL. So he is asking maximum power. That is V Thevenin square by 4 into RL. So V Thevenin, RL we want to find. V Thevenin is, first you can find R Thevenin. R Thevenin, this is short, this is open. So straight away R Thevenin will be, when this is short looking from here, 612 parallel. 612 parallel plus 3, this is open, again 2. So R Thevenin will be 9 ohms. R Thevenin, just simplify, you will get 9 ohms. Next you have to find V Thevenin when this is open. So when this is open, you can say this voltage is some value Vx. So you can write equation here. When this is open, no current here, 2 is entering. So 2 is equal to, what is leaving? Vx by 12, and this current is Vx minus 12 by 6. So solve for Vx. Vx answer is 16 will come. But what we want? V Thevenin. V Thevenin. So go like this. Under open, the here drop is 0. So 3 into 2, 6. 3 into 2, 6. And this voltage is nothing but Vx. So 16. Vx is 16. So total you will get 22. Therefore 22 square divided by 4 into R Thevenin. R Thevenin is 9. Simplify, you will get 13.44. So C is correct. Then this is easy question, 32. Among all, this is easy. So 40 volts given, is asking voltage across this. These two are series. So VR1 is equal to 40 into 100 by 100 plus 300, 400. We will get 10 volts. So this is easy question. Which one of the following represent a single element such as a voltage source or a resistor? So it is the branch. A branch may contain one resistor or one a voltage source, not the node, not the loop. Loop or circuit same only. So these three wrong, it is only a branch. So with this, these are the questions. Total 14 questions asked. Now thank you. Now I am requesting Professor Sarvan sir to continue the session. Thank you.
Right, good evening all. Let us see the questions that were given on communications, both analog as well as digital communication part. For the same average transmitted or modulated signal power and same average noise power in the message bandwidth, a coherent SSB receiver will have exactly the same output signal to noise ratio as. Means basically he is asking what is a signal to noise ratio at the output of your receiver. So which one will have the same value? Coherent DSB receiver, AM, VSB and SSB. So obviously the message signal bandwidth is almost same when you take SSB or VSB, both the signals are almost the same. Sorry, just a moment. Just a moment. Just hold on, just check it out. Yeah. So it's basically VSB or SSB, both can match here. So both the options have equal chances. So mostly because he is asking about SSB and also given the same option here. So I think both are possible here. Because both the message signals have the same bandwidth, in case of VSB as well as SSB, we can go for any of their case. Let us see the next one. Over a certain binary communication channel, symbol 0 transmitted with a probability of 0.4, 1 with probability 0.6. So he is given the probability of errors here. Probability of errors for 0 as well as 1 are given here. He is asking what is the total probability of error. So total probability of error, probability of transmission of 0.4, probability that 0 is coming in error is 10 power minus 6 plus probability of transmission of 1 is 0.6 and 1 is coming in error is 10 power minus 4. So you can simply write this as 0.0004 004 into 10 power minus 4 plus 0.6 into 10 power minus 4. So you can straight away say it will be 0.604 into 10 power minus 4. So this will be your right choice. Simple question. Let us see the next one. Which of the following noises arises in the electronic devices such as diodes and transistors because of discrete nature of currents? So here you have to filter out, don't read all the things. Basically he is asking in electronic devices and discrete nature. Straight away you can go with short noise. That is the definition of a short noise which arises in electronic devices. Next. Which of the following represents output signal to noise ratio of a uniform quantizer? So we know the signal to noise ratio of a uniform quantizer is 3/2 into 2 power 2n. But this is a case when you are going with single tone message signal. So you can see the options are almost the similar thing. So instead of n he has given as r. So what I am doing is just you take a normalized power of the message signal. It is nothing but power of the message signal by peak amplitude of the message signal. So if you take a single tone signal like a cos or sine, obviously for single tone signals the normalized power of the message signal is nothing but 1/2. So what we can substitute here, 3 you can keep as it is, and in place of 1/2 you can write PMN, which is the power of the message signal by peak amplitude of the message signal whole square, and then followed by 2 power 2r. I am just rearranging the terms, that is all, nothing is done here. So which will be the right choice here? 3 p by m square into 2 power 2r. I think here it is printed wrongly, but this will be the right choice. Okay, simple. Then removing the redundant information before encoding is a basic idea behind. So basically why we are doing the process of encoding to reduce the number of bits per each sample. So redundant number of bits means the samples which are very close by, the amplitudes which are almost similar, these can be removed or you can quantize it to the nearest predefined value. So this is nothing but the process of quantization. Theoretical bit, directly you can answer. Next. In which of the following techniques RF binary signals are transmitted as given? So which is the basic modulation scheme that you are using here? So here we are doing transmission of 0, this is like S1 of t, and transmission of 1 is like S2 of t. So you can straight away observe here, amplitude is same, frequency is same, which is changing? Only the phase is changing. So when phase is changing, Obviously, the modulation scheme that we use is phase shift keying. So, you can go with option C. Some questions are straightforward bits, so you can save lot of time in these type of questions. Now, coming to this statement 1 and statement 2 assertion reasoning model question. Shannon has shown that it is possible to achieve error-free communication by adding sufficient redundancy. So, what is the coding scheme we use in Shannon-Fanon coding? We add extra number of bits so that we can decode the error that is present at the receiver side. So, first statement is correct. Addition of extra check bits increases redundancy. Second statement is also correct. And second one is correct explanation for first one. So, we can go with option A. Next, which of the following statements is not correct? Noise performance of a full AM receiver is always inferior to that of DSP-SC. Correct, because the figure of merit which you get in case of standard AM is far less when compared with DSP-SC. It is a correct statement. The figure of merit of a DSP receiver using coherent detection is always unity. True. Figure of merit of SSB receiver using coherent detection is also unity. All these three statements are true. So, obviously, do not read statement D. You can go with that, because you can save little time if you do not read that statement. So, that will be the right choice. Next, RF carrier range and IF bandwidth correspond to AM receiver are respectively. So, basically he is asking bandwidth of AM signal, which is 2 into maximum frequency. Maximum frequency in AM we take 10K, so it will be 10 kilohertz. So, basically choices are either B or C. So, you know the range. What is the range of AM radio, standard AM radio? It will be around 535 kilohertz to 1605 kilohertz. So, only possible choice is option C. In that particular range, you can go with that case. Identify the given circuit shown in the figure. What is the nature of the filter that is asked here? So, depending on the circuit elements we have here, take some input and see what is the output you are having. You can take this also in analog circuits also. Depending on the type, we can because he is having a low pass filter here, the combination of this will be like an impedance part that is coming and a resistor. So, it can be an integrated circuit followed by a amplifier case. So, that is how you can identify the nature of filter. So, these are certain questions coming from the communication area. We have certain other questions also in advanced communication. I will take it little bit later after the other areas are covered.
Yeah, let's see the questions on digital. The first one is straightforward. I think we have seen it number of times, convert decimal to hexadecimal. So what I can do here is, this B, I'm going to say that by the elimination process, these two are wrong. Reason? The weight of this one is 16 square, that is 256. 256 into 2, this becomes 512, but the given one is 329 only. That's the reason. As it is 2 into 16 power square, this cannot be the answer, this cannot be the answer. So option has to be either A or C. And you know, by taking the normal process, the answer is correct one is A. Yes. And here, this 396 I want to represent in different forms. Better thing, what is the shortcut you need to do is, take the last digit and try to compare it with the last operation. Okay, that's going to lead to you the correct answer as quickly as possible. What is the XS3 code of 6 is nothing but it is 9, that is 1001. As you can see, none of the option has been given here, so all the answers given here are wrong. Next one, it is nothing but whatever may be the address size, 20-bit or 16-bit immaterial, but it's telling that for the 500th memory location, what is the value? Simple, any memory, it starts from 0 to 0 address. So 500th memory location means 499. So 499 decimal, convert this into hexadecimal. This comes to 1F3. So the correct answer is A. Okay. Of course, this is very simple one, but little logical, we need to be careful. The best method what I did for this here is, this can be written as the sum of minterms, that is 3, 5, 6, 7. You know that this is nothing but the carry output of a full adder. We know that for this we have two expressions. One is AB plus BC plus CA, and also it is equal to CI into A exclusive or B plus AB. While discussing, we keep deriving these expressions again and again. That's the reason the correct answers are C as well as A. If you are in a hurry, there is every chance of falling in the loop and you may pick only one answer, but actually two answers are correct here. Yeah, of course, here the circuit is missing here, and for that circuit, it's very simple circuit consisting of NOR gates and NAND gates. What is the final expression we get is nothing but D. Well, so here it is a 8:1 multiplexer. We have seen number of times how to implement a canonical SOP expression by using a multiplexer. Whichever minterms you want at the output, those corresponding inputs will be connecting to logic 1. Here he is asking for sum output of a full adder. I know that the sum output of a full adder is given by sigma m 1247. Means corresponding inputs of these should be connected to 1. I think where it is matching, we have to check it here. You can see D1, D2, D4, D7 are connected to 1. That's it. So the correct answer is B. Yeah. So he is asking what is the maximum frequency. Always remember the maximum frequency is equal to 1 by minimum frequency. Okay. So to know the minimum frequency, I should know what's the minimum value of this. I should know what is the minimum value of this. He has given the minimum value of this one is 16 nanoseconds. Minimum value of this one is given as 29 nanoseconds. That means T minimum is equal to 16 plus 29, it comes to 45 nanoseconds. Then F maximum is 1 by 45 into 10 power minus 9. So that comes to 22.2 megahertz. It is as simple as this. Okay. Right. So this is nothing but a 5-bit asynchronous counter. Okay, right. He is asking what's the frequency here. I told number of times the output frequency at MSB is equal to f by 2 power n. That is, in this case, it is f by 2 power 5. So that means the frequency is equal to 22.4 megahertz divided by 32. So this comes to 700 kilohertz. It's as simple as this. It won't consume more than half a minute. Right? So here he is asking what is the maximum modulus possible. if nothing is mentioned and he is asking about what are the modulus of a counter, we have to take it as a ripple counter, which is also called asynchronous counter. The expression for frequency of operation maximum is equal to 1 by n times TPD FF. So he has given maximum frequency 10 gigahertz. He has given propagation delay of the flip-flop. We need to calculate what is the value of n. From this, the value of n will come as 8.33. F maximum is 10 gigahertz and the propagation delay of flip-flop is 12 picoseconds. If you calculate, it comes to 8.33. That means I should take n as equal to integer, which is 8. It can't be real value, where n stands for number of flip-flops. With 8 flip-flops, what is the maximum modulus possible? So maximum modulus possible is 2 power n. That is 2 power 8. That is 256. So this is the answer. Again, half a minute for this is enough. Okay, I think this is simple De Morgan's law application for a simplification of Boolean expression. C is the answer for this. I think it's a matter of 1 or 2 steps. So here it may be little time consuming. So if you go to 8051 microcontroller, we have seen what are the specifications of all microprocessors, all microcontrollers in the class number of times. We need to memorize them. It should be on your fingertips. That then only you can easily recall it whenever it's necessary. The first one, 00 to 1FH, that is 32 locations, they are meant for register band, correct. 20 to 20F are available as a place to save the byte-sized data. No, this is wrong. The size of the RAM is equal to 128 bytes, correct. So he is asking which of the above statements are correct. 1 and 2 is the correct one. That's it. Why it is wrong? Because 20 to 20F is meant for bit addressable memory. Each bit of a location I can access it. That's the reason it's not meant for byte accessing, it is meant for bit accessing. Yeah, now if you look at here, I think this is very tricky. Even if you don't have the knowledge, I can answer this question. If you just have little bit of knowledge here. He told that non-volatile RAM. What's the meaning of non-volatile? That means even if power is removed, the information is not lost. Then the first statement, when the power is turned off, the contents are lost. This is wrong. What do you mean by that? In the given options, one should not be there. So if you look at the options, the option which is not having 1 is only this one. That's it. I think you can come directly without having the knowledge on this. Next one is 8259. It is a programmable interrupt controller. I think if you look at the specifications, 1 interrupt can be expanded to 8 interrupts by using this programmable interrupt controller. Also, one more thing I told in the class, by using 8259, 9 of them in master-slave configuration, we can increase INTR to 64 interrupts. So that is the possibility here. Let's see one by one. It is specifically designed only for 8085 microprocessor. Wrong. It can solve 8 levels of interrupt priorities. Correct. With additional 859A, the priority scheme can be expanded to 32 levels. No, it is expanded to 64 levels. So which of the above statements is or are not correct? It is 1 as well as 3. So correct answer is yes. So the thing you can observe here, the questions are not very difficult, but it's trying to make you fall into some trap. So if you are not very attentive, there is every chance to pick the wrong answer. Okay? Yeah, consider this 8085 instruction set. If you look at the DAD instruction, first try to understand what is asking here. First of all, what are not correct? This is very important. Okay, don't read the question. First see, is he asking the correct statement or is he asking incorrect statement? First you make it out, then you come to the options. Okay, DAD H instruction is going to affect the carry flag. This is the correct one. After execution of DCR instruction, sign and carry flags will not be modified. It is wrong, because DCR instruction, sign flag is affected, but carry flag is not affected. But he is saying that both are not affected. Incorrect. After complement carry, only carry flag will be changed after execution of the complement carry. So this is the correct one. So he is asking which one is the wrong one. That's only 2 only. So it is only skill, but not any knowledge here. You have to understand how to answer it in a technical manner. That is very essential. Okay? right? So this is number of times you have seen. How many memory chips we require is, I want 8 kilobyte divided by 1024 into 1 is the given memory size. This can be written as 8 into 1024 into 8 by 1024 into 1. So cancel it out, the answer is 64. So it's again very simple question. Okay. Yeah, so these are the questions appeared on digital and microprocessor. So you have seen we have hardly taken half a minute for every question. So I think you need to prepare to that level, then you can answer them confidently so that you will get the confidence in the exam as well. The remaining time you can use it for tough questions. Thank you, and I request my colleague Dr. Shiva to come and answer the questions.
Very good evening students, I am Shiva Subramaniam. I will discuss the questions from the electronic devices or basic electronics. The first question is, which one of the following statements is not correct regarding the carrier lifetime? So, try to clearly understand the technical words that he is using. It is a carrier lifetime. Okay. So, carrier lifetime, either I can say tau n for the electron and tau p for the hole. Okay. Now, the option A, carrier lifetime ranges from nanoseconds to hundreds of microseconds. So, first thing what is asking, following statements is not correct. This is very important. Okay. So, be careful with this, it is not correct. So, usually the carrier lifetime is going to be ranging from nanoseconds to the microseconds or the hundreds of microseconds. The statement A is right. Okay. Now, coming to the option B, on an average, okay, on an average a hole or an electron will exist. So, hole is going to be having the carrier lifetime of tau n, and obviously for electron it will be tau n, for hole is tau p seconds before it recombines. So, that is the basic definition of your carrier lifetime. So, this statement is also right. And before answering C and D, if you see the excess carrier, suppose if I say delta n is going to be equal to capital delta n into e power minus t divided by tau n, you can write. Okay. And suppose you consider delta p, okay, the excess hole concentration I can say, then what you can write, delta p is going to be equal to capital delta p into e power minus t divided by tau n. So, where this delta n, delta p values are going to be at t equal to 0. So, if I say here in this one, suppose you take t is equal to either tau n or t is equal to tau p. So, it is going to become 1 by e times, actually 1 by e times. So, 1 by e value is going to be how much? It is going to be 0.37, it is nothing but 37%. So, in the option C as given, tau n is the time it takes the total concentration to fall approximately to 63% of the initial value. No, it is going to be 37%. So, this statement wrong. Okay. And if you go for option D, tau p is the time it takes the injected concentration to fall to approximately 37%. Yes. So, the correct option is going to be option C. Statement wise it is wrong. Okay. See the next one. At what condition does the Fermi energy level, so he is talking about the Fermi energy level. Okay. Many times, many number of times we are going to discuss this in the class. Fermi energy level concept is going to be very, very important one. So, what he is asking is, it is going to lie exactly, okay, I think, yeah, between the band gap for intrinsic semiconductor materials, nothing but exactly it is located at the middle of the band gap. So, we know the basic formula for the Fermi energy level, EF is going to be equal to EC plus EV by 2 minus KT by 2 ln of NC by NV, okay, and which will be under root actually. And NC, NV are going to be the effective density of states, where you are going to have the effective masses. So, in this term you are going to have effective mass of the electron, and NV term you are going to have the effective mass of the hole. Okay. So, except other terms, except your effective mass of electron and effective mass of hole, all other terms will be the same. So, that is why, so you can replace this now, this I can write EF is going to be equal to, this is going to be the mid band, okay, minus KT by 2 ln of, I can say now simply Mn star divided by Mt star, which are the effective masses under root. Now, if your effective mass of electron is the same as effective mass of hole, I am going to get your Fermi energy level at the middle of the energy gap, as simple as this. So, this we will discuss directly in the class itself. Okay. So, for your understanding purpose I have given. So, option A, the effective masses of mass of a hole and a free electron are the same. So, straight away you can see this. So, other things you can skip. Okay. So, let me go for next question. Which one of the following statement is correct for N channel or P channel MOSFET? So, this also very straightforward we can answer. Suppose you go for option C and option D, he is talking about the input resistance. He is talking about the input resistance. Now, suppose you consider the JFET. In this case, we will write Ig approximately equal to 0. The gate current will be approximately equal to 0. And if I am talking about the MOSFET, we will see Ig is 0, because you have a reverse biased PN junction here, and there is a oxide layer which is going to insulate. Okay. So that is why you are going to have high input impedance in this case, but whereas you go for this, it is going to be very high input impedance. Okay. If you talk about the input impedance, and if you compare, JFET is going to have high and MOSFET is going to be very high. Okay. So straight away option C and D are going to be wrong. Okay. And if you are considering this is going to be the drain resistance of JFET is going to be more than the drain resistance of the MOSFET. Okay. So that is what the statement A is given, drain resistance of MOSFET is very larger than JFET, yes. Okay. Then what about option B, transconductance? Yeah, I am sorry, this is wrong. Okay. Transconductance and interelectrode capacitances have comparable values for the two types. So here whatever transconductance we are talking, for your NMOS and PMOS, they are almost equal to they are going to be the same. So option B is going to be the right one. Okay. So these are some of the questions from the electronic device. Now I will hand over the session to the next faculty, Sharavan sir.
Right, welcome back. Let us see the questions that were given in advanced communication area. The total communications means analog digital communication part and the advanced communication part. If you see the total number of questions coming on this, almost around 25 to 28 questions were given on these two subjects. So let us see the questions that were given in the advanced communication part. Almost all the questions are theory, there are no numerical on this. So let us just quickly go through these things, and pretty simple questions. Orbital satellites are, so we know they are synchronous because they rotate with the same speed, so they should be in synchronous, then only we can get the data. So they are basically synchronous satellites. Next, identify the given circuit. Actually I have taken this as the last question in my previous communication questions area. So you can identify this. We have an amplifier. The combination of this R and C is like an impedance part across capacitor. We have these branches in parallel and then R. So this is simply representing a high pass filter. So it comes under the pre-emphasis circuit. Right. Coming to the next one, the requirement for reliability, long life, stability, high efficiency and suitability. So here so many factors are given to you. The main factors which we have to look into consideration are stability and reliability. So these are given by which of these devices? Basically IF amplifiers are good, but their lifetime is quite less. So you can remove it. RF amplifier, less stable. Traveling wave tube amplifiers, absolutely they give very good stability and very good reliability along with long life. So that will be the correct choice. Coming to the next question, which of the following fibers has a distinct advantage of low intermodal dispersion? So he is asking which one has low intermodal. Be very careful. Generally when you study, you will have a confusion on intermodal and intramodal. So he is now asking on intermodal dispersion. So it will be multimode step index fiber. This will have low intermodal dispersions. So we have different types of fibers. When you read the characteristics of all the fibers, easily you can distinguish these options. Coming to the next one, the highest frequency that is returned to the earth at a given distance is called as MUF, maximum usable frequency. So basically on the curvature of the earth, if you have an antenna at two different places, so it is just like getting reflected back your signal. So this frequency to the maximum extent which you can use is called as maximum usable frequency. Simple questions. With frequency reuse, several cells with no space, means there is a clustered area. In a given coverage area, use the same set of frequencies. So he is using same set of frequencies. Two cells using the same set of frequencies are called as. So whenever you use same frequency, the interference which we get is called as co-channel interference. That is what we have studied. That is the actual line when we study about this co-channel interference. So he is asking what is the nature of the cells we have when such an interference can occur because of the same frequency. So only possible choice is they are co-channel cells. So hexagonal, adjacent, these are all the different architectures of our mobile communication area. But whenever the frequencies are same, the interference that occurs is co-channel. So based on that, the cells that are forming are called as co-channel cells. The component in the satellite that takes an uplink signal and converts into a downlink signal. Basically it is a communication area where you transmit and then you again receive it. So the one which does that work is called as transponder, that converts one frequency to other frequency and transmit the data from one point to another point. Basic terminology, basic definitions. An advantage of a passive satellite. So what do you mean by passive? And we cover this area under satellite communication, passive and active satellites. So when you have a passive satellite, what is a basic advantage? That is what he is asking. Advantage of passive satellites is that they do not require sophisticated electronic equipment on board. That is true. Although they are not necessarily void of power. Some passive satellites require which one of the following for tracking and ranging. Tracking and ranging means what? You have to identify the exact azimuth. Where is the location of the satellite and what is the nature of that particular satellite. So the one which does this work is your beam. So beacon receivers, radio beacon receivers. These are the devices which can identify the exact location of these passive satellites. Some of the diffracted light continues down the fiber and some of it escapes through the cladding. The light ray that escapes represent a loss in light fiber in light power, which is called as. So there is a light confusion on this particular question, because he is asking the amount of light that escapes through core and cladding and comes out. So basically, if you see these options, there is no chance that it is chromatic dispersion. It comes because of basically the wavelength. So he is not talking anything on wavelength. Chromic distortion is also not a choice. So possibility that it is Rayleigh scattering loss or predominant fiber loss. These predominant fiber losses comes as a major loss, means there is some major problem with the fiber manufacturing itself. Then we call it as predominant fiber loss. It's almost 99% of the light escaping from the fiber. Very few light will pass through the fiber. And Rayleigh scattering losses comes also during manufacturing process only. You know, these fibers are manufactured with glass. So whenever you melt glass at very high temperatures, there is a chance that small holes can be formed. When light propagates in that particular medium, the scattering that occurs there is what we call it as Rayleigh scattering. When it is very high, then there is a chance that this light will come out of the cladding and go into completely out of the fiber. So the possible choices are both A as well as D. So if losses are very high, then only we go for predominant. So basing on that, we can go with either of these two choices. Numerical aperture is closely related to acceptance angle and is the figure of merit commonly used to measure. So what is the purpose of numerical aperture? We denote it as NA. Generally we call it as light gathering capability of the fiber optic cable. So more than numerical aperture, the means is from lead or laser, whatever your source is there, light source, it can couple the light waves coming from that particular source. So basically it deals with the maximum angle of light ray. Sign of the maximum angle, magnitude of acceptance angle, these are not at all suitable. Intensity of the light we are not interested in. So it is a maximum angle at which your light will get coupled into the fiber. That is what we refer to as numerical aperture. This is straightforward formula question. In an antenna, we have an input signal, and at the receiver side, he is giving you the temperature. TA is the temperature and T is the effective noise temperature. These are all suffix, T suffix A and E. Refer to the input terminal. B is the bandwidth and K is Boltzmann constant. Then the output signal to noise ratio. So basically, signal power divided by total temperature equivalent, which is your TA and T sum along with KB. K is Boltzmann constant and B is the bandwidth. So here we take it as KTB. So this T whatever you are writing is total temperature, which will be sum of TA and T. It's a direct formula, you can straight away go with that. No need to waste more time on these type of questions. So these are the questions that have come on advanced communication area. So
welcome you for the questions on computer organization. So if you look at what he has given here is, I want to carry out multiplication of two signed numbers, especially in 2's complement form. So what's the method we are going to follow? Actually, by the process of elimination, we can tell the answer even if you don't know the concept. See, this K-map algorithm is not there. Okay, Pascal's algorithm, no. De Morgan's algorithm comes in digital. So as well you can tell directly by looking at these options. So the Booth's algorithm, okay, is the correct answer for this. Okay, right. Right. So some process is given in terms of steps, which involves MAR, MDR and control signal. Okay, and then in this, which of the correct one is here? So 1 and 2, 2 and 3, 1 and 3 or 1 to 3. Before I come to the options, as I always tell in the class, try to recollect what exactly the meaning of this one. So if you look at a CPU, what I tell it in the class is, whenever I ask the CPU to execute an instruction by providing its address, that address is loaded into program counter. So after that command, this program counter is going to have this address. And then how the CPU is going to fetch the instruction, what are the sequence of steps? I told number of times. The PC value is loaded into memory address register. This is the first one. The value on memory address register is sent on the address bus. This is the second step. After that, it is going to send the control signal saying that I want to read from the particular memory location, that is read bar is equal to 0. So this is step number 2 and this is step number 3. So because of this address, for example, one of the location is selected, and because of read bar equal to 0 from the memory, from this location, that whatever instruction or operand is there, that comes into memory data register. And from this memory data register, it goes into instruction register. So these are the sequence of steps I always tell in the class to remember. Now if you know this sequence, it's very easy to do this. What is the question here? Look at this. The first one is, address of the location from which the word is to be read is loaded into the memory address register. Okay, this is the first one is correct. Number 2, a control signal is given, something like read bar equal to 0. This is also correct. After that, in response to this address and this control signal, what the memory does is, it is going to respond with the whatever operand or data is available here, it is going to respond into the MDR. This is the third step. So corresponding to the memory delay, in reading the specified word, the required word will be loaded by the memory into the MDR. So this is also correct one. So he is asking, what are the things here is this thing. Select the correct answer using the code given below. So correct answer here is 1, 2, 3. So this is step 1, sorry, this one is step 1, this one is the step 2 and this one is the step 3. So all 3 are correct ones. Let's go to the next one. Which of the following addressing modes is used to compute the address of the operand by adding a constant value to the content of the register? Always you know the instruction is going to consist of 2 parts. One is opcode, second one is the operand A. Okay, right. So depending on the addressing mode, this is going to play a very important role. He is telling that this one is added to a register value, that is nothing but your index register. And then this is going to give the physical address, which is nothing but use it to access the memory. So whatever operand is given here, it is added to this index register value and it is going to produce the address. So the correct answer to this one is indexed addressing mode. Okay. Even by the process of elimination also we can tell. In immediate addressing mode, no question of adding anything. In direct addressing, the address of the destination is given directly. Name itself is suggesting here. Even in absolute addressing, it is given directly. So the correct answer is indexed addressing. Coming to the memory mapped I/O. I think while explaining this concept I told, you have to always remember the merits and demerits. Without looking at the options, in memory mapped I/O, what is the concept? In this memory mapped I/O device is also treated as one of the memory IC. That's the reason. Advantage I am going to get is same instructions I can use for memory as well, input output devices. But the disadvantage, effective memory space is going to reduce. Those are the highlights we have given at the time of explaining memory mapped I/O. So if you look at this, the first statement is the correct one. And if you look at the second one, the effective memory address space is getting reduced. Okay, this is also correct one. So the correct answer to this 143 question is both 1 as well as 2. These are the correct statements. Okay, like this one, if you know the concept, if you read the question carefully, we can answer to it without committing any mistake. Yeah, so which of these addressing mode is same as register indirect addressing mode? I kept, while introducing the addressing modes concept, the register indirect mode is going to resemble one more type of addressing mode, and that is nothing but auto increment mode. Okay, so in register indirect addressing mode, the effective address is given by a register. Let us say register R. And even in the case of auto increment mode, the effective address is given by register R only. Okay? You may ask me then, sir, what is the difference between the two? In the case of auto increment mode, after providing the effective address, the register is incremented. That's it. So I told number of times, this is the difference between the register indirect addressing mode and auto increment mode. Both are almost same, but for this change. So the correct answer to this is auto increment mode. Let's come to the next one. A floating point number is said to be normalized if the leftmost bit of the mantissa is. So whatever may be the mantissa given, you have to adjust it in such a fashion that the first bit, MSB bit, it should be a non-zero value. It should be a non-zero value. The reason, by default, we are going to choose it as explicit normalization. So once it is explicit normalization, we have to see that the MSB bit has to be compulsory 1. It cannot be 0. So the correct answer to this is A. Yeah. In order to keep track of the instruction locations, which one of the following contains the value of memory location assigned to the instruction or operand being processed? Actually, if it is whatever options are given is the right one, then none of them is the correct answer. I see that there is a typo in this. There is a typo. As of now, all the answers are wrong. Had he given this as program counter, then it is the correct answer. I think that it is a typo. Okay, it should not be ILC. There is no meaning for ILC. It should be PC. If it is PC, then it's the right answer. Yes. So you are taking n-bit numbers addition by using full adders which are connected in consecutive manner. You know, for any full adder or any binary adder, we can connect it either in ripple carry adder or carry look ahead adder. If it is connected in consecutive fashion, it will come through carry ripple through adder. Even by the process of elimination, we can observe that. Okay, none of the other things are going to be correct. Counter, it is observed. Carry ripple through binary, it's observed 1. Carry ripple through subtractor, it is exactly opposite of what we are expecting. So even if you do not know, for most of the questions, just by the process of elimination, I can get to the correct answer. Okay, right. So which of the following instructions are long and allow maximum parallelism since each bit controls a single control line? I told clearly a control unit is having many types and predominant type is horizontal microprogramming and vertical microprogramming. In horizontal microprogramming, all the control signals are given directly. In vertical microprogramming, all control signals are given in the encoded form. That is the basic difference between the two. So what he is asking here is, where is you are going to have maximum parallelism. So if you take so these are all the control signals and they are going to have simultaneous availability, and this is possible only if the control signals are available directly without any encoded form, and that is possible in your horizontal micro instructions. Okay? So that is the answer to this. Yeah, the last one in this computer organization is, whenever I am going to go for assembling of your assembly language program, what is the answer for the given question here? You know that assembling the assembly language program, we are going to use two-pass assembler. First it is going to pass through the entire assembly language program, and then second time it will go through one more time. That is called two-pass assembler. So in first passing of your assembly language program, what it does is, whatever symbols are available in your program, that will be dumped into symbol table. That will be dumped into symbol table. Okay? And in second pass, it is going to convert all the instructions into the correct instructions. Okay? So the correct answer to this is the symbol table. So these are the questions appeared in computer organization, and they are very easy except one or two, and you can easily score out of them. Now I request my colleague Venkateshwar sir to cover the questions on operating system. Thank you.
So now we are going to see questions on operating systems. So here we have only two questions from operating system, and there is one question from computer networks which comes under advanced communications. So these three questions I am going to deal here. Have a look. The first question, which is from operating systems. Which one of the following is the entity that can combine object modules that may have resulted from assembling multiple assembly modules separately? Option A, compiler. Option B, interpreter. Option C, linker, and option D, loader. See here, we can easily eliminate one option from this particular word, object modules. Based on this particular word, we can eliminate interpreter here, because interpreter cannot generate, it won't generate object modules. So programming languages that uses these interpreters, such as JavaScript, Ruby, Python, these are the programming languages which can use interpreters. But when it comes to the C, C++, Java, these type of programming languages uses compilers. So what exactly compiler is doing here? Have a look. So for example, if I write a program, let's say that program is said to be source code. So for example, if I write a program for addition of two numbers, I can save that file with .c extension. Let's consider that I'm writing C programming here. So if I write a C program, then that program is called source code, and that source code is having an extension of .c. So then when I start execution of this, before execution, what I can do? I can compile this particular source code. I can do compilation here. So when I do compilation, so this particular compiler is verifying for errors, right? In the C program, in this whatever the source code I am having, in that source code, whatever the errors it is having, those errors can be identified by this compiler. So after compilation, so here after compilation, it generates, let's say this is my compiler. After compilation, it can generate .obj files, .objects files, you can say, object file it is called. So these objects files and some extra files like library files, some extra files which are called library files, can be combined by a operating system utility which is called linker. So linker combines this So now we are going to see one question from computer networks part, which is comes under advanced communications. Look at the question statement. The internet protocol IP is the heart of the TCP/IP protocol suite. IP corresponds to the network layer in the OSI reference model and provides option A connectionless service to the application layer which requires a virtual circuit. Option B, high reliability in the packet delivery. Option C, a connectionless best effort delivery service to the transport layer. Option D, reliability functions within a higher layer protocol. So this is the question related to this internet protocol. See, try to recall internet protocol features or else functions you can consider, characteristics. So IP characteristics are the first characteristic, which is, it provides unreliable connectionless, it is a unreliable connectionless protocol. This is the first characteristic of IP. So here itself we can say it is providing unreliable service. It is providing unreliable service. Unreliable service in the sense after transmitting the data, no acknowledgement is being provided, right? So if you verify the among the options, here it is mentioned that high reliability. Actually, it is not providing reliability. It is providing unreliable, right? It is providing unreliable service. So that you can ignore this option B here. And option D, if you verify, it is also saying that reliability functions within a higher layer protocol. But as we clearly mentioned that IP is a unreliable connectionless protocol. So that option D also can be ignored here. So what is the answer here? Among option A and option C, if you verify, it is saying that it is a connectionless service. It is a connectionless service, right? Both are connectionless service only, right? Both are same. Then to the application layer, but you know, here upon the network layer, we are having transport layer, right? If you recall this TCP/IP reference model, we are having total layers like 4 layers. People used to say 5 layers also. Among them, if we verify first, physical layer plus data link layer combinedly, this is one layer, which is host to network layer. Upon this, we are having internet layer. Upon this, we are having transport layer, and then it is having application layer. See, this layer is providing service to the transport layer, but not to the application layer, right? So here, if you verify, it is mentioned that a connectionless service to the application layer. Here itself, I can filter this option A here. So that option A is wrong. So what else remaining? So simply you can say option C is the answer for this question. Best effort delivery. What is the meaning of best effort delivery? No error checking and no tracking. Means after transmission of the data, which packet is lost, which packet is successfully transmitted. This is not the sense of the IP protocol. But IP protocol can do error control with the help of a protocol called ICMP protocol, right? So hence option C is the answer for this question, right? Next, look at the next question. Yeah, this is the straight question we have from operating system functions. Look at the question statement. Which one of the following functions is not correct? See, this is a point which we have to understand here. Not correct, and it is mentioned that functions of operating system. Operating system functions, if you verify, operating system is responsible for memory management, it is responsible for IO management, it is responsible for process management, right? So if you look at option A, allocating storage and memory, what does it mean? This comes under memory management. So operating system does that, right? Next, coming to the option B, handling basic input-output operations, which is IO operations. This is also done by operating system only. This is also the functionality of operating system. Next, coming to the option C, providing protected shared of the computer among the multiple applications. See, this is also saying that it is related to the security and protection, right? So not and protection is one of the another functionality of operating system, right? Next, coming to the option D, quick execution of instructions, but this is not an operation of a function of operating system, right? This is the operation of our device which is called central processing unit, CPU, or else you can say processor, but it is not a functionality of operating system. So hence option D is the answer for this. It is not the function of operating system. Remaining 3 are functions of operating system. Okay, so this is the part from operating system and computer networks. Thank you.
Good evening, children. In control system asked 12 questions. The questions are medium. And come to the first question, it is a statement. So a transfer function is a function which relates the current or voltage at the one point to the current or voltage at the another point. It is a current. It is a this is correct statement, because transfer function is nothing but it may be output current by input current or output voltage by input voltage. The second statement, if the transfer function has one or more poles in the right half of the S-plane, then it is called a non-minimum phase system. This is also correct. In non-minimum phase system, one or more poles may be in the right, or one or more zeros in the right, or both may be in the right half of the S-plane. So both are correct statements, but statement 2 is not a correct explanation of the statement 1. So option B is correct. Second question. A unity feedback system has the given system. So H of S1 is given. What is the value of K if the steady state error asking is less than 0.1? So you want steady state error ESS is less than 0.1. So for unit ramp input, the steady state error ESS equal to simply A by KV. KV is nothing but numerator constant by denominator constant. So unit ramp means A is 1. So simply KV is called numerator constant by denominator constant. What is the numerator constant? K. Denominator constant will be 1. So that means here K. So which should be less than 0.1? Which should be less than 0.1. So that means which is less than 0.1. But here A is given. What is A? So step and ramp input is given. For step input, the A is, 1 minute. The for step input A is 0, and for ramp input A is 5. So 5 by K equal to 0.1. So 5 by K less than 0.1. So K is greater than 50. K is greater than 50. The answer D is correct. So here the combination of step and ramp input is given. For step always steady state error, because it is type 1 system. For step steady state error will be for 0. For ramp will be A by K, but A is given here 5, that's I written. So K is called numerator constant by denominator constant, that is K, which should be less than 0.1. So K is greater than 50, that is the answer I written. Next one. So for the given control system, what is the value of K? So that there is a 10% in steady state error. So that means steady state error equal to 10%. 10% means it is nothing but 0.1. It is nothing but 0.1. So this is also type 1 system. Type 1 system gives the constant steady state error for the unit ramp input. That means A by K. So A is 1. What is K? Numerator constant by denominator constant. What is the numerator constant? 5K divided by denominator constant 6 into 7 into 8 is the denominator constant. That means what you are getting? 6 into 7 into 8 divided by 5K. It should be less than 0.1. Less than 0.1. You solve for K. K will become 672. 672 you will get. K will become 672. It will be equal to 0.1. Equal to 0.1. You will get answer K is 672. Next one. Underdamped system. For underdamped system, rise time is 0% to 100%. Underdamped system, rise time is 0 to 100%. But he has given what? 0.1 to 0.9. So actually this is correct for overdamped system. Whatever it is, the correct option is the rise time. So they should give actually 0 to 100% they have to give. But here given 10% to 90%. This is actually correct for overdamped system. It is correct for overdamped system. Next one. So the open loop transfer function of unity feedback system is given. So by what factor should be amplifier gain should be multiplied so that the damping ratio increased 0.25 to 0.75. So if you write the characteristic equation here, what you will get? Tau S square plus S plus K equal to 0. So then if you bring into standard form, S square S by tau plus K by tau equal to 0. So if you get a relationship between zeta and k, if you get the relationship between zeta and k, zeta is inversely proportional to 1 by root k, you will get 1 by root k. That means I can say k is inversely proportional to 1 by zeta square, 1 by zeta square. So if I consider zeta 1 is 0.25, if I consider zeta 1 is 0.25, and for this the gain I consider k1 in case, and zeta 2 is 0.75, 0.75 consider, I proportionally gain I consider k2, simply k2 by, I'll write here, simply k2 by k1 is nothing but zeta 1 by zeta 2 whole square, zeta 1 by zeta 2 whole square. Zeta 1 is 0.25 divided by 0.75, 0.75. So whole square, that means it is nothing but 1 by 3. Whole square means it will be 1 by 9. 1 by 9. 1 by 9 means 0.1111 you will get. That means answer A is correct. Next, consider the following statement regarding the feedback compensation. So feedback compensation decreases the rise time. That means the first statement is going to be correct, because faster response means rise time is going to be decreased. And the environmental condition always affect the what? System stability. So that means the second statement also correct. The accuracy, the cascade compensation increase the accuracy of the system. That's the third statement also correct. That means option D is correct. Next question. So consider the speed control shown in figure, wherein inner loop corresponding to the motor back EMF, the controller is an integrator with the gain K. So this is the integrator with the gain K. Observe that load is inertia only. What is the value of K for which steady state error to a unit ramp input is less than 0.01? We want error ESS is less than 0.01. For that you have to find the G of S. This total function is nothing but G of S. So find the G of S. So if you find G of S, what you will get here? For example, first I simplify this loop. So if you simplify, you will get 10 divided by S, opposite sign of the feedback means plus, numerator term 10, product with 0.1 means it will become 1. So this block gain having series with K by S. So that means K by S. So G of S become 10K by S into S plus 1. It is a type 1 system. Type 1 system for ramp input gives the constant steady state error. So what is the steady state error? A by K. A by K. So A is 1. So K is nothing but 10K. K is nothing but 10K, which is less than 0.01. Which is less than 0.01. So if you solve for K, K should be, K will become greater than 1 by 0.1. That means K is greater than 10. So the answer is C. Next, the subsystem that generates the input to the plant. So to the plant, the input is nothing but controller output. That means the subsystem is a controller. So the answer is A. Next, consider the following statement regarding compensator. The lead compensator reduces the noise level. So wrong. Lead is always improves the noise level. So introduction of cascade lead compensator increase the gain crossover frequency, cascade speed. Correct. So lead compensator always improves the speed of the response. Lead compensator always increase the bandwidth of the system. So that means 3 also correct. So the answer is C. 2 and 3 are correct. Which of the following are used when cascade compensation does not employ in pure integrator? Integrator is 1 by S. It is nothing but a low pass filter. So low pass filter. So but the disadvantage of integrator is it affects the system stability. The disadvantage of integrator is affect the system stability. So we can replace integrator by the lag compensator. So option B is correct. Next, which one of the following technique can be used to analyze the design the effect of loop gain upon the system's transient response and stability? Transient response and stability given by the what? Root locus technique. Next, consider the following statement regarding the time response specification. Delay time is the time, actually delay time TD, it is the time for the what? 0 to 50% of the final value, 0 to 50% of the final value. So that means the first one is wrong. Peak time is the time required for the response to reach the what? So second one is correct, to reach to the peak of the overshoot. Settling time is the time required for the response to reach and maintain behind the space. This is actually 2%, not the 3%, 2% and 5% of, this is also not initial value. They mistake, printing mistake may given, this is the final value, this is the final value. So then statement 3 is correct. So answer is 2 and 3. Answer is 2 and 3. Okay. Next, Subramanian sir will continue.
Welcome back dear students. So we will discuss remaining 2 questions from the electronic devices or basic electronics, and also we will discuss the advanced electronic questions. So let us see the question. Consider the following statements regarding comparison of one device is field effect transistor. Okay, what is the FET with the bipolar junction transistor. So we will clearly give this comparison in the class, the comparison of BJT as well as the field effect transistor. Now see the first one, BJT is less noisy than field effect transistor. No, the main disadvantage with your BJT is the reverse saturation current is going to double for every 10 degree rise in temperature. Okay, so there is a thermal runaway problem. Okay, so that is not there in the field effect transistor. So obviously your BJT is going to be more noisy than the field effect transistor. So if you know this, you can straight away answer this question without reading the second, third statements, because you see option A you have 1, option B you have 1, option D you have 1. So you can straight away eliminate all these options. So option C is going to be the right one. Only for your purpose I am reading the remaining statements. So FET is current control device, whereas BJT is voltage control device. So this is also wrong. We know clearly FET is going to be a voltage control device and BJT is going to be a current control device. Now coming to the third statement, FETs are more temperature stable compared to BJTs. Yes, that is the one advantage associated with your field effect transistors. The fourth statement, FETs are simple to fabricate and occupy less space on the single chip, nothing but the integrated circuit. Again, this is one more advantage. The number of fabrication steps that are required if you compare field effect transistor and the BJT, FET is going to have less number of fabrication steps, as well as it is going to occupy less space in the integrated circuit, which is a very important parameter. So 3 and 4 are going to be the correct. Okay, let me see one more question I need to answer from the basic electronics. Yeah, this one. Which one of the following is a transfer characteristic of N mass, okay, with the standard notations? So option A, this is actually for the field effect transistor we are going to use. We know very clearly that is nothing but the JFET, I can say, and this will be obviously wrong, and this is going to be your transfer characteristics, okay, which I can have ID is going to be equal to K times of VGS minus VT whole square for the N mass device, and this will be the wrong one. So option C is the right here straight away. Okay, yeah, let me see the remaining questions. Yeah, so these are from advanced electronics. So straightforward questions actually. By reading the question itself, we can able to answer the questions. Which of the following are not the production methods for carbon nanotubes? So he is asking with respect to carbon nanotubes. The first one, electric arc discharge method. So he is asking not, please, this word is very important now. Okay, if you miss that, obviously you will give wrong answer. Okay, so this is we are going to use. Then laser vaporization method we are going to use. Third, Czechoslovakia method, no, we don't use it. Metallization method also I am not going to use. So it is going to be 3 and 4, option C. He has given, I am not going to use, please. Okay, see the next question. So which of the following requires additional process steps in their fabrication process? Straight away you can see option A, thin film resistor, which is the main disadvantage or one of the disadvantages associated with the thin film resistor. Let us see the next question. In monolithic integrated circuits, the concentration of acceptor atoms in the region between isolation islands will be. See the options. Option A, much higher than in the p-type substrate. Yes, this is the answer straight away. Okay. Next one. Which one of the following statement is not correct for CMOS technology? He is asking with respect to CMOS technology, and with what he is comparing is bipolar technology. He is comparing with the bipolar technology. Now option A, CMOS technology has low static power dissipation, one of the main advantages associated with your CMOS. Yes. Now coming to option B, CMOS technology has high input impedance. Yes, because we know if you go for BJT and you compare the input impedance with your field effect transistors, obviously your field effect transistor is having higher input impedance than the bipolar junction transistor. Then coming to option C, CMOS technology has high delay sensitivity to the load. Yes, And coming to the option D, CMOS technology has high output drive current, okay, but this is wrong actually, okay. In this aspect, which we can call it as the fan out, this will be more for your bipolar technology. So he is asking which one of the following statement is again not correct. Please be careful, okay. So answer is going to be what? Option D is the answer for this question. See the next one. Consider the following statements, okay, regarding mass circuit design. Mass circuit design, okay. The statement 1, mass circuits are formed on 4 basic layers: N diffusion, P diffusion, polysilicon and metal, obviously, which are isolated from one another by thick or thin silicon dioxide insulating layers. Yes, this is the correct statement. Now coming to the second statement, thin oxide, which we can refer as thin-ox, mask region includes N diffusion, P diffusion and also the transistor channels. Yes, this is also the correct statement. Now coming to the third statement, polysilicon and thin-ox regions interact so that a transistor is formed where they are going to cross one another. This is also the right statement. So option D is the answer for your question. Let us see the next one. The ratio of total number of transistors on the chip to the number of transistor circuits that must be designed in detail is known as, the different options given is capacity, regularity, design efficiency, design density. So straight away I can say it is the regularity, okay. See the next question and last question here. Which one of the following technology consumes less power? Again, it is a very straightforward answer, okay. It is going to be the CMOS, okay. That is a main advantage associated with the CMOS technology, okay. Yeah, so with this, basic electronics and advanced electronics I have completed. So I will hand over the session to Kiran sir.
Hello. Thank you, Subramaniam sir. Good evening. Let's look at analog circuits. The Schmitt trigger can be used as which of the following? Square wave generator, comparator or astable multivibrator. Now we all know that a Schmitt trigger is a bistable circuit, right, or a flip-flop, because it's got memory in it. So it should not be astable. If it's not astable, then option 3 is wrong. So fortunately A is wrong, C is wrong, and D is wrong. So we are left with only B, right? So 1 and 2, that is the answer. So you don't have to look at 1 and 2, so that should be the answer. Thank you, sir. Okay. What are the approximate values of T1, T2 frequency and the duty cycle? Now, the first impression is, do we have to calculate all of them? Because as a student, we keep thinking, if we can eliminate, right, of a 555 timer used as an astable multivibrator. Now, we know that the simple formula for period is 0.69 RA plus RB into C, and T2 is 0.69 RB into C, and the frequency F is 1 by T, which is 1 by T1 plus T2. Now, I have tried to calculate with these values RA, RB and C, and I found that option A is the correct answer. So, it is a simple substitution problem, right. Now, in resistance levels, the AC or the dynamic resistance of a PN junction is defined as. Now, what do you mean by the word dynamic? The word dynamic means change, right. So, he says a point on the characteristic. So, this itself is a violation there. A point can never be a change, right. So, this is wrong. Now, what is the other word of dynamic resistance? Dynamic resistance means it's calculated from the slope. So, we all know that slope is the tan of the angle or the tangent drawn at that point, and it can't be a straight line between two limits, and the ratio of current by voltage. So, that is utterly wrong, because resistance by Ohm's law is voltage by current, it can't be current by voltage. So, option B is the right answer. Now, which one of the following is correct regarding stability factor? Now, I think I do not have to do this, because this is a standard formula. The stability factor is change in IC by change in IC naught. Now, which one of the following statements is not a correct for typical H parameter values of a transistor? Now, unfortunately, I never knew that such a question can be framed, because generally lecturers would probably write a table like this, where they have the H parameter values. This is like H11, H12, H21 and H22. So, this is the short circuit input resistance, but he just called it as input resistance. Now, H12 is the reverse voltage gain, that is an open circuit. So, there is no open circuit here, and this is the short circuit current gain. So, he did not mention it, he just said current gain. So, these are the typical values for CB, CA and CC. Now, students keep asking me, how do I remember these values? I just tell them that you do not have to remember. I am a lecturer, so I have to remember this. So, 1 stands for HI. So, this guy is HI, and this is HR, and HF and HO, right. Now, what are these typical values? So, it is unfortunate that the comparison of these values is actually framed as a question, right. So, the common base, if I remember, this is typically 30 ohms. This is 4 into 10 power minus 6. It is minus 0.99, 8 into 10 power minus 7. I usually give this in the class, so that you can frame a question, right. For common emitter, I give 1K here, 10 power minus 4, minus this is HFE is 100, this is 12 micro. So, H11 is 1K here, this is 1, this is minus 101, and this is 12 micro. So, now the question is, I think 99% of the students, I am really sure, now you have to be honest on this, would have not observed the fact that the HFE of the common emitter is positive, whether the common base and common collector are negative. But usually what happens is, when you solve a problem with an amplifier, not with a BJT, the common emitter is going to give you a negative value and the common base and common collector are going to give you a positive value. But mind you, this is a transistor. So that means a transistor is analyzed with 2-port. And what is a 2-port notation? You have studied in networks. Both the current should enter the port. So when you take a CE amplifier, these currents are actually entering the port. So only the common emitter is positive, the other values are negative. So it's unfortunate that anybody who remembers this can crack this question. But how a student can do it? So in my opinion, if a student at least knows that there is ohms at the emitter, there is kilo ohms at the base, and there is hundreds of kilo ohms at the collector, probably he can come to a conclusion that the output conductance is low in case of common emitter and common collector as compared with common base is a wrong option, because common collector output resistance is low, so its conductance should be high. So this is wrong. So that's how, but the fact is these are typical values of the BJT which we actually give to a student, but unfortunately it's been framed as a question, right? Now this is a lollipop question, a circuit that amplifies the difference between the two signals. The word difference is there, there's differential here, so that's the right answer. That's it. My friend would continue, right? So he's going to take electromagnetic fields.
Good day. Welcome friends. I am Vivek Narsampalli. I am going to deal with the questions which are related to the electromagnetic fields. Here is a question, statement and assertion type question. The statement here is, the antenna is a transformation device converting the electromagnetic photons into circuit currents. In the receiving mode, when the electromagnetic waves incidents on the antenna, that means the energy packet in the waves or photons you will call will be converted into the currents. So this statement is correct.
This statement is correct. And the second statement, antenna converts photons to currents or vice versa. Yes. Antenna is you can use the antenna for the transmission purpose as well as the reception purpose. Yes. So it converts the photons to currents in the receiving mode. In the transmitting mode, it will convert the currents to photons. This is also correct. But the reception is because of the acceleration of the charges. So the second statement is not the explanation to the first statement. Option B is the answer you can give. So the both statement 1 and statement 2 are individually true, but statement 2 is not a correct explanation to the statement 1. So the option B is the answer. Fine, let us take the next question. It is a direct question related to the Poisson's equation in the spherical coordinate system. You can remember this one from the standard form, 1 by h1 h2 h3 dou by dou u h2 h3 divided by h1 dou v by dou r and so on. Fine. So yes, so here you can represent this one. Actually this is a printing mistake, here it is rho v. So this, you can represent this entire thing, it is a Laplacian operator. So which is del square v is equal to minus rho v by epsilon. It is a Poisson's equation. Fine. If the rho v goes 0, it is become the Laplacian equation. So it is a very straightforward, it is a Poisson's equation. Fine, very straightforward question. Next, intrinsic impedance of the free space. Very popular question in the engineering service paper. Yes. So your electromagnetic uniform plane waves, if you consider the intrinsic impedance in the free space, which is equal to mu by epsilon naught, whose value is equal to 120 pi, and this can be approximated to 377 ohms. So option C is the answer. Very straightforward. Let us take one more question. Yes. Which of the following is the angle at which there is no reflected wave? That means whatever the incident wave is there, it will get completely transmitted into the second medium. That happens when the wave is incident at the Brewster angle, and that too wave must be of a parallel polarization. The concept of Brewster angle or the total transmission is only valid for the parallelly polarized wave and when it is incident at the Brewster angle. Fine. And the Brewster angle formula can be given as theta b parallel, which is equal to tan inverse of square root of epsilon 2 by epsilon 1. Generally we do not use this notation, subscript parallel. Yes, because it is understood that this is valid only for the parallel polarization. But to be perfect, in the question it is clearly mentioned that it is a parallel polarized wave. Let me check question number 114. Yes, parallelly polarized. It is clearly mentioned in the question. It is a parallel polarized wave. So obviously this will be what is called a Brewster angle is the answer. Very straightforward. Fine. He has maintained a clarity in the question framing. Fine. Let us take the next question. Here is a question. Yes. The condition for the low loss transmission line is, yes. So for the no loss transmission, what is the loss causing elements on the transmission line is a resistor and the conductance. So for the ideal transmission line, R and G must be 0, but in the practice, low loss transmission line, R value must be less than omega L and G value must be less than omega C. So option C, this is a direct condition. Generally we will discuss all these conditions in our classroom. No loss, low loss and distortionless transmission line. This is a distortionless transmission line. LG is equal to RC. Generally I will say, to remember the student, something like a LG is equal to RC. RC. You can easily remember this one, isn't it? LG is equal to RC. That is a simple way to remember this one. LG TV is equal to RC. RC. Just a second. RC. You can you remember in that way. Fine. Anyhow, the question is for the low loss transmission line. For the low loss transmission line, the condition is this one. A resistance must be far less than omega L and the conductance must be far less than omega C. Now let us take the next question. Here is a question. You need to little bit think about this one. Fine. Consider the following statement regarding the impedance matching. Yes, suppose if you consider the transmission line here, the transmission line is terminated with certain load ZL and having the characteristic impedance Z0. Suppose if I replace the load with its own characteristic impedance, what happens? Whatever the incident wave is there is completely absorbed by the load. So there won't be any reflection. But observe here, what is the first statement? Read this one carefully. When the line is terminated in an impedance other than its characteristic impedance, that means if the load impedance is not equal to characteristic impedance, what happens? The reflected wave will occur and there will be a standing waves of voltage and current. Okay. The line which may be very large if there is a considerable mismatch. Yes, first statement is correct. What about the second statement? The single stub device has the advantage that it will match any load. Yes. Suppose if you consider the transmission line, generally we do not expect the load. Load can be anything. It can be antenna or it can be a microphone. That is not in our control. If you want to match this one to the transmission line whose characteristic impedance is Z0. What is the fundamental matching technique is a single stub matching, isn't it? Suppose if I connect a stub here, this is called length of the stub, this is the location of the stub. Fine. Interestingly, this single stub matching technique can be used to match any load. It could be a real load or it could be a complex load. It is valid. But what is the issue with the single stub matching? Single stub matching design is for the different loads, you need to change the location. You need to make a holes to the transmission line and you need to shift this one. Not only that, you need to change the length of the stub. That is the issue with the single stub matching. That is the reason why we'll go for a double stub matching. Anyhow, as far as this statement is concerned, this statement is correct. Single stub matching device has the advantage that it will match any load. Yes, that is correct statement. Okay, fine. But what was the issue with the single stub is for a different loads, you need to make the hole to the transmission line. You need to change this length as well as this length. That is the reason why we'll go to the double stub matching. What is the double stub matching? Let me draw this one. This is ZL and having a characteristic impedance of Z0. So we'll use some two stubs here. These are one stub, there is a other stub. Okay, fine. There will be some spacing here. The issue here is the locations of this one. These two are fixed. You are not changing the location of the stub on the transmission line. So for the different loads, what you need to change? You need to change only the length of the stub. Interestingly, the location of the stub is fixed. So generally used stub matching technique for the wide range of impedances is a double stub matching. But there is a problem with the double stub matching is there is some forbidden region. You cannot match certain range of impedances. That is the reason why the complete solution will obtain in the triple stub matching technique. Anyhow, let us focus only for this statement. What is the third statement is the double stub has a disadvantage that the line length needs to be adjustable. Yes, true, correct. So if the load is changing, this location is fixed anyhow, but you need to cut differently this one. The stub size, stub location is fixed, but the stub size must be different. That is a disadvantage with respect to the, according to this statement, don't compare it with the other stubs. According to this statement, yes, that is a disadvantage. What must be the ideal stub, ideal matching? If I place some stub, it must match to all the impedances, but that is not the case. Fine. According to this statement, obviously this is a disadvantage. Suppose if the load is changing, I need to change the length of the stub here. Fine. So it is better than this one, but it also has some disadvantage. One is a forbidden region. The other one is you need to change the length of the stub for the different loads. Anyhow, this statement is also correct. So let me turn the page here. Options are provided 1, 2 and then 3. Option D is the correct. Fine. Okay. Let us take one more question. It is a very direct, straightforward. You need to choose the things very wisely here because there are confusing 2 here, 2 here, 2 here. Don't be in a hurry. Yes. You can also recall the inequality. Generally, we will consider these properties. This will consider in the topic of the properties of the waveguides. There are 3 properties. One is the intrinsic impedance, other one is the wavelength, third one is the velocity. Those 3 properties are true for any guided medium, whether it is a parallel plate or rectangular or circular waveguide, those properties remain same. Fine, anyhow, you can directly decide here, but let me talk some few lines about this one. Here is the inequality, eta Tm is less than eta Tm is greater than eta Te. Generally, I will give the technique to remember this one easily. What is the technique? Last term, last. And the remaining terms here. It is very easy to remember. Yes? And the high pass filter term will come in the denominator. Fine? So, here in the question he has represented this one with a Z. It is called wave impedance or characteristic impedance, whatever it may be. So, eta Te is equal to eta or eta Tm divided by, you will going to get the high pass filter term 1 minus Fc by F whole square. Or you can also write in terms of the angular frequency, omega c by omega whole square. Remember, it is a high pass filter term. Waveguide is a high pass filter. Fine. So, what is the answer here? You can check out. You can check out here. You can also write in terms of the angular frequency, omega c by omega whole square. Option C is the answer. Let us take one more question. Yes. Here is the thing. Which one of the following is the ratio of power lost per unit length to the twice of the power transmitted? Generally, we will use this definition in the waveguides to find out the attenuation. Yes. So, how this can be written is attenuation is equal to, answer will be attenuation factor, but it is a power lost per unit distance divided by 2 into total power transmitted. You can if you want, you can write in terms of words. Fine. So, this is the definition for the attenuation in evaluating the attenuation constant in the waveguides. Fine. So, what is the answer here? Attenuation factor. There is a small, you can prove this one with 4 or 5 steps. Let us not go into that. Fine. Here is a question. A section of X-band waveguide with the dimensions OK, A and B are provided, has a perfectly conducting walls and is filled with the lossy dielectric. Conductors are perfect, but they are filled with the lossy dielectric. If the dielectric is lossy, what happens to the permittivity? Permittivity will be the complex value. And the conductivity is also provided here. Of the dielectric is, let me check out this value, 119. 119, yes. 367.5 micro Siemens per meter, epsilon r is 2.1, mu r is equal to 1. Conductivity is very small, loss tangent will be negligible. Fine. So, if the loss tangent is negligible, you can write down that point here. Let me finish the question here itself. So, the epsilon r is a complex in general. So, which is equal to epsilon r into 1 minus tan delta. It is a loss tangent. Here the loss tangent is negligible. Why? Because a conductivity is micro. Fine. So, you can just ignore this part. You can just ignore that part. If you can ignore that part, what happens to this complex relative permittivity is epsilon r. Okay, fine. Now he is asking us to find out. Now our approach will be very simple. He is asking us to find out the cutoff frequency of the TE10 mode. Fine. So, what is the cutoff frequency of the TE10 mode? Fc is equal to TE10, which is equal to 1 by 2 into square root of mu naught epsilon r dash, which is equal to epsilon r itself, into m by a. M value is 1 here, very straightforward. m value is 1 divided by a. Substitute all the values properly here, and you can decide the answer from the options here, because the calcs are not allowed, isn't it? Fine. So what happens to this one? Fc is equal to Te10 is equal to 3 into 10 to the power of 8 divided by 2 into square root of epsilon r dash is equal to epsilon r, which is equal to 2.1 into 1 by a. What is this one? 2.286 into 10 to the power of minus 2. This square root of 2.1 is 1.44. Fine. So here it is 1.44. That means approximately 1.5. Yes. So 3 divided by 1.5 is 2. So 2 divided by 2 is 1. Yes. And 1 divided by 2 into, it is 1 divided by 2, something 0.5. Yes. So 0.5 into 10 to the power of, here you can bring this one into the numerator, 0.5 into 10 to the power of 10. That can be written as a 5 gigahertz. So the nearest answer will be 4.53. See, he has maintained the distance between the options, isn't it? He has not given 4.23 different options. Here it is 2, here it is 4, here it is C, isn't it? Obviously, you need to decide from the options here. So what will be the answer here? Exact answer will be option B is the answer. And even you could check out this one, if you with the help of, without calc itself you can answer, but you can check out the answer with the help of calc. So exact value will be, the exact value for this one is 0.452 into 10 to the power of 10, which can be written as 4.52 gigahertz is the answer. 5.2 or 5.3, yes. Okay, now let us move further. Here is a question here, a theory question here. Antenna or array designed to yield the directive gain appreciably greater than the obtainable from the uniform distribution has become known as, it is called a super gain array. Yes, and it is also called Hassan-Woodyard antenna also. There is other name for that one. It is a theory bit. Let us have one more question. Yes. Here is a question, little bit analysis is required, some standard results you need to remember to solve this one, otherwise it will become. Yes, let us try to get this one. The average value of the electrostatic field over the volume V of the sphere due to a point charge Q somewhere within the sphere where R naught, here actually it is R naught, here it is R naught. Okay, here it is R naught. R naught is a position of the charge is. So it is asking the electric field, average electric field. Fine, you need to use the Gauss law here, and you need to remember some, if you can, yes, let me consider here, there is a sphere. Let us consider whose radius is A. But inside this sphere, the charge is located at a distance of R naught. The charge is Q. Fine. Now what I will do here, whatever the electric field you get outside that one, that look like as if it is coming from the point charge. Fine. Now let us consider here, I will consider, suppose if this charge would have distributed over this sphere, whatever the electric field will give, the same electric field you will going to get. Fine. So what I will do here, I will find out the electric field here, and later I will going to substitute at the place of A, I will substitute the R naught. From there I will get the answer. Fine. So let us try to apply the Gauss law and try to find out the electric field at A. Fine. So what is the Gauss law here is a closed surface integral of E dot dA is equal to charge enclosed ENC by epsilon or epsilon naught. Fine. Here it is epsilon naught, small printing mistake here. So here it is Q by epsilon naught. You can bring this E outside. So E electric field is outwards. So here it is a closed surface integral of dA, which is equal to Q by epsilon naught. What is the surface area of this one? 4 pi R naught square. Yes. So here it is 4 pi R naught square into q into epsilon naught. Now let us adjust this one according to the options here. As I said earlier, I have calculated somewhere at a distance of a, just a second. I have calculated the electric field at a distance of a, that means here. But the question is asking over the volume. So in the place of a, I will substitute r naught. Fine. So this will become 4 pi r naught square into q divided by epsilon naught. Now let me do according to the question, let us do some adjustments here. I will complete the question here itself. So how this can be written? I will divide this one as 4 pi by 3 into r naught cube. So equivalently you need to multiply here. You need to multiply with the 3 into epsilon naught r naught. But what is this part is a volume of the sphere. Fine. So you can just bring that part, this entire part that side. This entire part that side. So the electric field E is equal to q into r naught 3 into epsilon naught into V. Yes. So this is the average electric field. Why we are taking it as an average electric field? Why? Because I have considered this charge, if I was not mentioned, but since the question asked regarding the average electric field, even though the point is mentioned as a point charge, I am considering it as if it is distributed uniformly over the radius of r naught. Fine. That is the thing here. So what is the answer here? Q into r naught by 3 epsilon naught into V. Let me check the options here. They are not properly printed. Let me correct myself. They are printed option A and option 137. Yes, 137 option was here, there was a minus here in the exam. Option B was, yes, here it is q into r naught into, here it is epsilon naught. Here it is in the exam, this was the question. So option C is the answer according to your paper. Fine. There is one more question. Let me turn the page. Yes, here is a question. Little bit lengthy, but you can logically answer this one. We will not go into the exact derivation of that one. Yes, see here in the relation between the field and the potential, if r is less than a, then the potential at point r inside the uniformly charged sphere of radius a is asking the potential, not electric field. Fine. So there is a standard result for the electric field. Now if you consider the sphere here, if the charge is distributed uniformly, yes, and the radius is also provided in the question. How much is the radius? Radius of this one is a, but the question here asking is at r. Is asking what is the potential here. Fine. So what I will do here, potential here with respect to this one I will do. Fine. There is some standard result here. This is a radius a. This is r. Fine. See here, from the standard result, if the charge is distributed uniformly in the volume, what is the electric field? That means at r less than a, what is the electric field? The electric field, this is a standard result. Electric field is equal to rho v into r divided by 3 into epsilon naught. The electric field inside the uniformly charged sphere varies linearly, proportional to the radius. Fine, this is a standard result. So once you have got electric field, you can find out the potential between some 2 points, and later you can find out this one. I will take this as the initial point, this is a final point. I will find out the potential here. And to reach this initial point, you would have already done some work, some memory, some residue. You can, as I said earlier, you can do this problem logically without going into a complete derivation. Fine. So let us try to get the potential here. So what is the potential here is V of r minus V of a. I will just take the magnitude here. I will consider this as the initial point, this is a final point. So here it is magnitude of a to r. I will just take the scalar part here. So here it is Vr minus Va, magnitude is equal to minus of a to r into, you can substitute this part. So here it is rho v into r divided by 3 epsilon naught into r. You can just bring the constants outside. So here it is Vr minus Va. Yes, so here it is minus of rho v divided by 3 epsilon naught. What is the integration of r is a r square by 2. Limits are from a to r. You can substitute and observe that minus sign inside. So Vr minus Va modulus is equal to rho v by 6 epsilon naught. R square minus a square, and if you observe that minus sign inside, it will become a square minus r square. So this will become Vr is equal to rho v by 6 epsilon naught into a square minus r square plus Va. We'll stop here and let us check the options here. You need to find out the potential at A. Again, there is a one more part, second part in this derivation. But no. Observe the options here. Hold on. Observe here. Something striking here. 6 is there. Rho v by 6 epsilon naught. Yes, and there is a square minus r square plus k a is there here. That means you need to integrate it from minus infinity to this point. That is something like a residue, memory. Again from here to here is a r. We are not going to do that second part. Again, what you need to do, actual procedure is, you need to apply the Gaussian surface here. Again, you need to find out the electric field. Again, for that electric field, you need to perform this integral. But intuitively, with our common sense, you can just say that there is a 6 here and there is some extra part is adding up. 2a square is getting added up. Yes, so that will be contributed by this part. So we are not going to do that next part of the derivation. Fine. Obviously, the answer will be option B. So these are the questions, these are the answers which are to the questions which are asked related to the electromagnetic theory. Okay. Good luck. I wish you success. I'll hand over the session to the other faculty member.
Right. This is Ramesh. Now I am going to discuss the questions on basic electrical engineering. The first question is to measure of a coil's ability to produce the flux. Simply the ability to produce the flux is nothing but direct answer. This is magnetomotive force. Direct question. MMF, magnetomotive force, force which moves the magnetic lines we can say. So that is what he is asking. To produce the flux, the force is magnetomotive force. Simple direct question. Let us see the next question. In this, which of the following is not a part of? Be clear guys, it is not a part of nuclear reactor. Not a part of nuclear reactor. See, moderator will be within the nuclear reactor. Biological shielding is required, as well as reflector. All these three are used in the nuclear power plant we can say. So therefore, direct answer is economizer. The economizer is used in thermal power plant. So therefore, not used is economizer. Now the second question is here. Which of the following is a merit of nuclear power plant? If you see the options are little bit lengthy. That's why go by an elimination process. What is that? Nuclear power plant merit he is asking. And the two, he is asking advantage notation. If you see that, large quantity of fuel storage facility is required in nuclear power plant. This is wrong. Actually, the point is the small quantity of fuel storage is sufficient because uranium we are using, not large quantity of space is not required. The maintenance cost of hydro power plant is very low as compared to the steam and nuclear. It is also a drawback. So therefore, it is as merit, but this is drawback of nuclear power plant. Next one is, as compared to thermal power plant, the space required for nuclear power plant is less. Definitely, because in the thermal power plant, coal storage, coal handling plant, ash storage, ash handling plant will be there. So this is correct. The initial cost of nuclear power plant is higher, means it is nothing but drawback. So therefore, if you are eliminating all the drawbacks, automatically advantage is the C option. Now let us see next question. Here, which one of the following temperatures exists for the magnet? The next question is, which one of the following statements is correct regarding Leclanche cell? So very simple. In the Leclanche cell, what is anodic plate as well as what is cathodic plate they have given. In this entire question, you need to understand that which is the anode plate and which is the cathode plate. In this, the D option is directly correct. If you see that, the resultant voltage is 3.5, but this is generally 1.5, wrong. And the zinc powder acting as a cathode, but actually speaking, zinc is acting as anode. So therefore, it is also wrong. Manganese dioxide acts as anode, but this is a cathode. So this is also wrong. If you see that, it is manganese dioxide cathode correct and zinc is anode correct. So option D is the correct one. Let us see the next question. And which one of the following statements is correct regarding induction motor? So in the induction motor, simply if you draw the slip torque characteristics like this, S is equal to 0 and S is equal to 1. If it is a lower slip, the torque will be linearly proportional, and we know that. And if it is a higher slip, it will be inversely proportional to the slip. So that we can say at low slip speed, at low slips, the torque is directly proportional to the slip. So direct answer, based on the formula, direct answer. Now let us take next question. What is the coil pitch to eliminate the fifth harmonic in the induced EMF of synchronous generator? Simply what we can say, 180 by N. Which harmonic you want to eliminate? So fifth harmonic. So therefore 180 by 5, you will be getting 36 degrees. So therefore direct answer is 36 here. And these are the questions from the basic electrical engineering subject. Next.
Right, here I am going to discuss about material science for this ESE 2022. Now, it is a straightforward question, that is the atomic packing factor of simple cubic structure. The atomic packing factor of simple cubic structure, here it is given. So, the atomic packing factor is nothing but it is the fraction of the total volume of atoms in the unit cell by volume of unit cell. You can remember directly, the straightforward question, atomic packing factor of simple cubic structure is 0.52, directly you can remember. Now, the second question, for some solid materials each atom possesses a permanent dipole moment by virtue of incomplete cancellation of electron spin or orbital magnetic moments. See, the magnetic dipole moment generated in the material, especially at the atomic level, because of incomplete cancellation of their spin of electrons, and due to that there is a rotation of electron and spin of electron. So, directly the first answer, that is option A, is the correct one for this question, right. So, this is the easiest question, basic fundamental question. Now, this is somewhat complex, but in a simple way we can understand, we will get the answer here. Which one of the following statement is not correct regarding laminates? Okay, now, so the first statement is given, paper is not correct here. Remember, this is not correct. Paper reinforced laminates can be used in thickness ranging between 0.2 mm to 50 mm. So, it is very difficult to remember the values here. No one will remember. So, leave it, just take it aside. Now, take second option. Paper reinforced laminates are used in applications involving power frequencies and voltage up to 1 kilowatts, 1 kilovolts even. This is also a number value, number statement. So, even no one will remember this type of values, all these things. So, leave it. Now, come to the third one. Glass reinforced laminates make use of phenol formaldehyde as an impregnate and adhesive. Now, first of all, what do you mean by glass reinforced polymer? Laminate. See, it is a composite material. You are familiar about the composite material. In a composite material, there is a reinforcement phase material and the matrix phase material. Okay, glass reinforced. Okay, glass reinforced polymer, otherwise glass reinforced matrix phase as a polymer. Glass is a reinforced material. So, here reinforcement phase material is a glass, and matrix phase material GFRP, we call it as glass reinforced polymer. Matrix phase is a polymer and reinforcement phase material is a glass. Now, here the phenol formaldehyde is a polymer actually. The phenol formaldehyde is a polymer as a impregnant. Here you have to remember this word impregnant. Impregnant is also known as a reinforcement phase material, that is a high strength material in the composite. So, the polymer here, it is a matrix phase, the reinforcement phase, that is a impregnant material, is a glass. So, this statement is not correct. So, in the question it is given which of the given below is not correct. So, this statement is not correct. So, answer is C directly. Right. So, these statements you no need to recall the numbers also. It is very difficult to recall, that is why I am going simply option C is the correct one. And option D is asbestos reinforced laminates have higher electrical characteristic than paper reinforced laminates. It is statement is right. In the question it is given which of the given below statement is not correct. So, answer C is the correct one. Now, which one of the following statement is not corrected? Here also not corrected regarding mercury. So, it is in the question it is given mercury is a heavy silver white color. This is the statement that is right, because the mercury color is white silvery color. So, this statement is right. Next, the specific weight of mercury is approximately 31.55 grams per centimeter cube. So, it is very difficult to remember these values. So, leave aside this. Now, come to the third one. Mercury is the only metal which is a liquid at room temperature. That is right. It is the only metal that is liquid at room temperature. And the boiling point of mercury is approximately 357 degrees Celsius. Yes, right. At room temperature it is a liquid, so boiling point at 357 degrees Celsius it convert into vapor, right. So this statement is also correct. So this is one right, this is one right, this is one right. Generally the specific weight of the mercury is lesser than this one, I think approximately 13 point something. So this is not correct. So in the question it is given which of the given below statements are not correct. So the B statement is not correct. For this question answer is B. Now the next one, see in the question it is asking interplanar spacing especially for FCC structure, right. The face centered cubic structure basic type of unit cell is cubic. So the interplanar spacing for a cubic material, that is A by root of h square plus k square plus L square. This is the basic formula. Now for FCC structure material we know that A is equal to 4r by root 2, that we call it as 2 root 2 r, we can write it as 2 root 2 r. So 2 root 2 into atomic radius 0.125 is given divided by root of Miller indices is given in this 2 3 1. So 2 square plus 3 square plus 1 square. So it's a simple one. By solving this you will get the answer, the most appropriate answer you will get 0.94 nanometer. So the correct answer for this question is C. Now the next one, when a bar is subjected to a rapidly alternating magnetic field, there is a rapid extension and contraction in the length of the bar. That phenomenon is known as, see here, if you apply the magnetic field to a material, especially a magnetic material, the magnetic material generate compressive and tensile stresses in the material, that we call it as a mechanical strains. Okay, that behavior is known as a magnetostriction. It's a straightforward definition question, magnetostriction. So the correct answer for this question is C. Right. The next question is a material composed of C60 molecule, C60 molecule, C suffix 60 molecule that contains 60 carbon atoms in the network of sp2 hybridization bonding, which forms a spherical structure, is known as, see, C60 molecule is known as a Buckminsterin Pullerin. Okay, the Buckminsterin Pullerin is a scientist name. He was invented the C60 nanomaterial. It's a 0-dimensional nanomaterial, right. So it's a spherical in shape. So the answer for this question is A. Right. Now the next one, the electronic properties of the nanotubes could be changed between the metallic and semi-conducting simply by varying. Now see here, what do you mean by nanomaterial? What do you mean by nanomaterial? The nanomaterial means at least one dimension of the material is varying from 1 nanometer to 100 nanometer, right. Okay, now in the question it is given, which is given nanotubes, okay, carbon nanotube. What is a carbon nanotube? It's a one-dimensional material. That means, okay, here the length may be any length, but the diameter must be within this range. Okay, the diameter must be within this range. So by changing the diameter, we can change the properties, right. Either by decreasing diameter or increasing diameter within this range, we will change the properties like conducting to semiconductor, semiconducting to insulator, like that. So the most appropriate answer for this question is by changing the diameter of the tube in a simple way, right. Next, another question here. It's a very simple question. A very low temperature where the resistivity of certain material abruptly plunges from a finite value to one that is virtually 0 and remains there, and further cooling is known as, it's a very simple, it is related to superconductivity. It is related to superconductivity or a superconductor. The superconductivity was invented by the scientist Onnes. It was invented the first metal, that is a mercury. Mercury is becoming superconductor at 4.12 Kelvin. Right. So based on that we can understand that, now I am considering the y-axis is the magnetic field and x-axis is the temperature. Okay, at 0 temperature, 0 Kelvin temperature, there is a more magnetic field is required to destroy the superconductivity, and at a transition temperature, okay, we call it as a critical transition temperature. There is no magnetic field is required. So this is the temperature. Less than this temperature, material is a superconductor. Above this temperature, material is a normal conductor, right? So that is known as a critical temperature. It's not knee temperature or ambient temperature or Curie temperature. So straightforward, the answer for this question is C, critical temperature, right? Now the other one, superconducting materials are used in which of the following applications? The superconductor is a zero resistivity material. So we can use this material as a lossless power transmission lines, and also we can use this material. We are using this material especially maglev trains, magnetic levitation trains, and also magnetic resonance imaging in hospitals, especially in MRI scanning purpose. We are using it as a superconductor, and also magnetic resonance spectroscopy to analyze the spectrums of the materials, and also switching circuits. Okay. And also we are using for high speed switching circuits and signal transmission for in the computers, especially supercomputers, we can use this one. So all the applications are correct. So the most appropriate answer for this question is D. Most appropriate answer for this question is D. Now the next question here, consider the following statements. Now see here, some materials are capable of absorbing energy and then re-emitting visible light in a phenomenon is known as luminescence. It is correct. It's a straightforward basic definition questions, right? So first one is correct. If the delay time between the absorption and re-emission is much less than 1 second, that phenomena is termed as phosphorescence. Phosphorescence. This is not correct. If the time is less than 1 second, that is known as a fluorescence. Okay. Now see here, third statement is, if the delay time between the absorption and re-emission is greater than 1, is termed as fluorescence. Reverse it is given. Actually, the fluorescence was to be here and the phosphorescence was to be here. So both statements are not correct. So 2 and 3 are not correct. So only first statement is right. So the most appropriate answer for this question is A. Right, simple basic question. Now the final one, here it's a statement question, where a simple basic type of question. Now see here, some of the common familiar polymers are polyethylene, nylon, polyvinyl chloride and polycarbonate, polystyrene and silicone rubber. These are the basic polymer materials. Okay, now right. So some of the common and familiar, right? So this statement is right. Polymers include familiar plastics and rubber materials. Yes, rubber is also a polymer. It's viscoelastic polymer. So this is also right. Statement 1 and statement 2 are right, but statement 2 is not a reason for the statement 1. There is no particular explanation of the statement 2 for the statement 1. So I'll give you, for this question, I'll give you option B. Okay, what do you mean by option B? Statement 1 and 2 are correct. Statement 2 is not the correct explanation for statement 1. So answer for this question is B. Right. So next, our colleague will continue this.
Right. Now I am going to discuss the questions from the measurement subject. The question is straight away here. the measurement precision of an instrument defines the smallest change. The point here is, he is talking about smallest change. So automatically, smallest change means without any second thought, we can go for resolution of the instrument straight away question. The two, smallest change in measured quantity. So therefore automatically answer is resolution of the instrument. Right, straight away question. Let us take the next question. That is, it is transducer based question, little bit numerical model. The point is, the output of a LVDT is connected to a 5 volt voltmeter through an amplifier whose amplification factor is 200. Let us take the small diagram here. This is LVDT, right? This output is connected to one voltmeter, right? This is connected to one voltmeter like this. But through an amplifier, this is one amplifier. Its gain is how much? 200. Gain is 200. What is the voltmeter scale? 5 volt is given. This is what the circuit. And sir, here an output of 2 millivolt appears across the terminals of LVDT. So therefore, across this, how much? 2 millivolt. 2 millivolt is appeared here. And here, when the core moves through a distance of 0.5 mm, so therefore it is given as 0.5 mm. And then the millivolt voltmeter scale, 100 divisions are there, and the scale can read to 1/5 of a division. It's very, very important point. The number of divisions are 100, but 1/5 of the division can be measured. They are asking sensitivity and the resolution. Sensitivity and the resolution. So the simple point, what is the sensitivity of the system? Very simple. The output by input notation along with the corresponding total value. If you are taking change in output by change in input notation. What are the values they have given? So 2 millivolt. The amplifier gain is 200, correspondingly 5 mm. If you are taking, you are going to get the sensitivity as 800 millivolt per mm will be there. 800 millivolt per mm. If you see the options, two are there. 800 millivolt per mm, 800 millivolts. So therefore, we can cancel A and D. After that, sir, what is the resolution? What is resolution? 5 volt is there and 100 divisions are there. The two, each division, right, 1/5 of the each division can be measured. So therefore, the corresponding 5 volts with respect to 500 and what is that? 100 into 5, because each division will be having 1/5, therefore 500. If you are substituting that and along with this data, you are going to get the value as 1.25 milli mm or 1.25 into 10 power minus 3 mm we can say. So therefore, you will be getting 1.25 into 10 power minus 3. Now you can verify. So which is the answer? 1.25. Yes, this is what the answer. Right? Question is very lengthy, but if you go step by step, if you are able to draw the diagram, LVDT and correspondingly voltmeter. One is sensitivity and one is correspondingly the resolution he is asking. Right? Now, next question. Here, this is also very lengthy. In this question, right, unnecessary data is there. You need not to and you should not get confused at all. That is, the coil of a recording ammeter length 65 mm long, 25 mm wide. The rated current of the coil is 10 milliampere and the flux density in the air gap is 0.0046 Weber per meter square and the damping constant is 0.008 Newton, right? Newton meter per radian second, and the moment of inertia, different data is given. Moment of inertia 0.008 kg per meter square, kg meter square. The spring constant is given in terms of Newton meter per radian. The Coulomb friction is given. The number of turns of the coil. So what you require? Number of turns he is asking. And to produce a deflection of, this is 100 degree. This is 100 degree. A rated current is approximately. But the moment if you see this, definitely many people will leave this question. But generally if you understand this, what we require simply in a corresponding which device? The coil of a recording corresponding ammeter. So therefore, sir, at final steady state position, Tc equal to Td. What is Tc? Kc into theta is equal to B I N into A. If you are holding this point, other data is not required in this. So therefore, Kc is given, theta 100 degree, but you must be very careful. Theta is given in degrees, that must be converted into radians. Why? The Kc is given in terms of corresponding radians. And B is given, I is given, A. Every value is given. If you are simplifying, you are going to get, of course, for this definitely calculator based operation only, but numerical they have provided like this. If you simplify this, approximately you will be getting the answer as the corresponding near to this value you are getting. So therefore, among the available options, the appropriate one is option A. So you are going to get the n values like this. This is somewhat difficult numerical based question. Let us take next question. That is, consider the following statements regarding data acquisition system. Data acquisition system. Some 3 statements are given, but be clear which are not correct. Which are not correct. So very simple. Which are not correct or which is correct, etc. they have given. Go by the option elimination. First of all, simply, digital data acquisition systems are used when the physical quantity being monitored has narrow bandwidth. Yes, so digital data acquisition system generally suitable for narrow bandwidth. So therefore, this is correct. But he is asking not correct. So therefore, the third 3 numbers should not be there. If you see the options everywhere, 3 and 3 is there. So automatically straight away you can eliminate the options like this. That's why if you are following the point for digital data acquisition, automatically yes, narrow it, suitable. So therefore this is suitable. Therefore in the answers 3 should not be there. So answer will be 1 and 2 are wrong for the based on question. Next question. Here wave analyzer is also known as, generally wave analyzer is generally called as level voltmeter or selective amplitude, selective voltmeter, etc. Therefore, among all these, selective level meter also we can say direct concept based question. Wave analyzer other name is, what is it? The amplitude selective voltmeter we can say. So therefore, simply selective level meter is the answer. Right. Next question. Here, what is the displayed rise time? Approximately he is asking. When a pulse waveform with a rise time of 21 nanosecond. So what is the given data? Rise time. What is it? 21 nanosecond they have given. And is supplied to an oscilloscope that has an upper cutoff frequency 50 megahertz. Right? What he is asking? Corresponding rise time he is asking. The 2 displayed rise time he is asking. Very simple. But in this, 2 steps will be there. What is that? Sir, we know that rise time formula 0.35 by bandwidth. 0.35 by bandwidth. Sir, 0.35 by. What is the bandwidth they have given? 50 megahertz. 50 megahertz. If you simplify this, you will be getting 7 nanosecond. 7 nanosecond. This is the rise time based on the. Now, what is the other formula? It's a rise time, that is displayed rise time. So measured rise time should be equal to the given rise time, waveform rise time. Therefore, what is that? Simply 21 nanosecond square plus corresponding, what is that? Oscilloscope rise time we can say 7 nanosecond whole square. If you are simplifying this, you will be getting approximately 22 point something. You will be getting approximately 22.13. So answer will be yes. So you will be getting 22.13 nanosecond. So suitable answer is 22. In the question also he has mentioned approximate value S. So therefore the answer will be yes, 22 nanoseconds. Now the next one is, it is also somewhat numerical based question. That is here. 4 strain gauges are mounted on a simple flat tensile specimen arranged for complete temperature compensation, and maximum sensitivity when connected in a 4-arm bridge circuit. Of course, 4 strain gauges, that is simply 4-arm bridge circuit is connected. And 8 into 10 power 5, this is 8 into 10 power 5. 8 into 10 power 5 ohm. Calibration resistor is shunted across one of the strain gauges, and the strain gauge resistance is given as 188 ohm, and the gauge factor is 1.22. What he is asking? Gauge factor he has given. Then the effective strain, he is asking the strain. If you are able to recollect the formula directly, what is that? Strain gauge, correspondingly you will be having the, what is it? Relation between resistances and all. So what is that? This is the gauge resistance, this is the corresponding shunted resistance. If you are taking that, epsilon is equal to gauge resistance by N into gauge factor Rg plus RSH. If you are able to recollect this formula directly, if you are substituting all the values, Rg 188 given, yes 188, and N is given as 4 branches, and gauge factor is given as 1.22 he has given, yes 1.22, Rg plus RSH. If you simplify this, you will be getting the approximate value as 48 into 10 power minus 6, or you will be getting 48.1, only calculation part. In this year, from the measurement subject, 2 questions are completely given based on the numerical based. So other than that, there is no other procedure. Simply have the entire calculation, get the value, answer will be C option. And next one is very simple question. A 0 to 200 volt voltmeter has a guaranteed accuracy. GAE is given 1% of full scale reading. Of course, guaranteed accuracy error itself is with respect to full scale value. The voltage measured by this instrument is 150. You need to treat that as true value anyway. And the percentage limiting error is, sir, what is the formula? Direct straight away question. Percentage limiting error is full scale value 200 by true value 150 into plus or minus 1%. These type of questions we have solved so many in our classes, but only values are different. You will be getting 20 by 15. So therefore, if you are simplifying that, you will be getting 1.33%. So therefore, answer will be D, direct straight away question. And let us take one more. Here, a voltage has a true value of 1.55. and analog indicating instrument with a scale range, full scale is given, shows a voltage of 1.48. What is the relative error? So relative error is nothing but simply epsilon r, that is also called as percentage limiting, but he has given in terms of percentage, therefore we need to take percentage limiting error. So therefore percentage relative error, or we can write percentage limiting error also. What is the formula? AM minus AT by AT into 100. AM minus AT by AT into 100. In this, the full scale value usage is not there. So what is AM? 1.48 minus 1.55 by 1.55 into 100. If you simplify this, you will be getting approximately minus 4.5, minus 4.516% is the answer. So approximate value is minus 4.52 is the answer. And these are the questions from the entire measurement subject. Finally, these are the total questions from the entire exam, and those who have written and those who got the good score, congratulations to them. And those who are ready for mains examination, all the best. Thank you.